Okay. Right, we'll start. We'll start. Good evening, all. How are the audio, online students? Okay, it's fine, right? Right. Okay, good evening again. We'll start. I can notice a small lag. What about the video? Is it also lagging? No, right? No. Right. For the ones who joined online as like newbies today, I'll be uploading the paper for my Telegram channel and sending you the link. Right? I'll send the link there. Otherwise, on WhatsApp, file sending is not allowed. You know it. On WhatsApp, sending files in WhatsApp channels is not allowed. Right? I'll upload it to the Telegram and share you the link. Right. For others, distribute this. Give me 2 minutes, online students. Registered ones, you can go and download the paper from the website. I mean, for the newbies. Give me 2 minutes. Give me 2 minutes. I will send the paper and send you a link. Yeah. Yeah, I'll put it to the Zoom chat and YouTube chat. Right. Okay, so today we are writing paper 3. Right? We are writing paper 3. And we have finished writing 2 papers. And about the last one, since we had how many questions to be discussed? One is it? One is it? Are you 2? Right. I uploaded the marking scheme, I think on Tuesday or Wednesday or somewhere around that. But I didn't make it visible until Sunday. So now, after Sunday, I mean after yesterday, it is visible now. You can go there and download and check your answers about those questions, right? And if there are if there are doubts from most of you about the questions there, I'll be taking that to discussion again, right? First, go through the marking scheme with your answers and check it against the given answers, right? And if there's anything that you didn't understand in the marking scheme, let me know, right? Then if the case is same for the majority, I'll take it to the discussion again, right? Okay, then here, let's go to first 10 questions. First 10. Now it's 6:40. I'll be giving you time until 6:52 for first 10 questions. Try first 10 questions. 6:42. 6:52. Start now. I'll send the paper. Online students, I have online new students. I have pinned a message on YouTube chat. So you can go there. There's a Telegram link. Go that link and you can download the paper there. Either you can get it from the website. If not, I'm not logged into the Zoom from my personal device now. If there's anyone who are joining on YouTube or joining on Zoom, you have access to YouTube, just go there and can anyone get the link and paste it on the Zoom chat? Put it to the main chat. Downloaded. Okay, good. Thanks, Hafil. Okay. Now it's all fine, no? Finish. Check again. Yeah, just 3 minutes more. Check again. Tell me if you notice any typos or something like that. Huh? Please count it. Oh, ඒක හොයාගන්න ඕන. මේ divisions දීලා දෙන්නේ නේද? Centimeters නේ. හරි. Are you doing chemistry or IT? Chemistry. IT ගන්න අය වදින්නේ IT. ඔය දැන් විතරයි නේ. Okay. Right, let's see. I got your okay. Right. See. Right. First one. Consider following quantities used in physics. Right. Electric current, mass, thermodynamic, temperature. Which of the above is our base quantities of international system of units SI? Right. Tell me what are the 7 physical quantities we have? Mass, time. I think in the first paper itself also we had one question from SI quantities, isn't it? Okay, mass. What are the 7 physical quantities? These are very straightforward theory question. Mass, length, what else? Time, right? MLT is anyway there. Then thermodynamic temperature. Thermodynamic temperature. What else? Electric current. So when we say currents, actually the reason is there are different types of currents. So that's why we specifically say electric current, right? So in the future, especially in thermal parts, also you will learn there are different types of currents. Huh? Amount of substance. What else? 2 more. Sorry, only 1 more. 6. Luminous intensity. So you should know all 7, right? You should know all 7, whatever the question is. What are the basic units of these 7 quantities? Mass, kilograms or grams? Kilograms. Length, meters. Time, seconds. Thermodynamic temperature, kelvins, capital K. This is a simple K, right? This is a simple K. That's the difference. Electric current, amperes. Amount of substance, moles, simple M, simple letters, luminous intensity, simple C, simple D, candelas, right? If you write this is wrong, making past papers, capital C, simple D. What is this? Cadmium. This is cadmium, right? Unit 10, cadmium. Dana, ICT करना है दरना, cadmium दरना. Right. Which of the above is a base quantities in international system? Okay, then electric current is a base quantity, mass, thermal temperature, all ABC. 5. All ABC. Second one. The percentage error of a certain length measurement has to be kept below 1%. By the way, what is the maximum allowance of percentage error we are allowed in laboratory measurements? I have explained this several times. What's the maximum percentage error we are allowed to have in measurements? Only 1%. Yeah. Only one. Right? To have the error 1%, what's the minimum reading we should take from meter ruler? 10 centimeters. Right? If the error due to the measuring instrument is 0.5 millimeters, the measuring length has to be greater than. Error of a measuring instrument, or the maximum error of a measuring instrument, is also the least count. Right? So error least count 0.5 means that is the least count of the instrument. Maximum error a person does when dealing with the instrument is the least count. Something like this. Say, look at the board. Right, if you don't know that, just look at the board. Say you need to take the reading here at this point. Now this is the calibration we have. Right, this is the calibration we have. Let's say this is in centimeters. Right, this is the calibration we have. See, now someone tries to take this reading, the reading here. Someone tries to take this reading. Right, now 2 centimeters means 20 millimeters. No? Right, let's go with millimeters. This is 20, 21, 23, 22, 23. Right, this is 24. This reading is in between 23 and 24. Right? Okay, looking at the scale, tell me what is the least count here of this instrument? What is going to be the least count? What is going to be the least count here? What is the least count of this instrument? 1 millimeter. Right? Least count of this instrument is 1 millimeter. Right? Now, a person tries to take this reading. This is between, what are the values? This is between 23 and 24. Right? So someone could read this as 23 because we don't have any idea about the divisions here. No divisions at all. That's why we don't have any idea about the amount to which degree this is extended here. We don't know. So someone could read this as 23. Still, someone could read this as 24. Got it? The divisions, there are no divisions mentioned in between. Therefore, if someone reads this as 23, the minimum reading it's going to be is 23 millimeters. If someone reads this out as 24, the maximum reading the person is going to read this as 24. Error between these two is 1 millimeter. No? That is exactly equivalent to least count. So therefore, maximum error that we could have using any instrument is equivalent to least count. Right? Then make a 23 කියවන එක 27 වගේ කියවන්නේ නැහැ නේ එහෙම track. උනොත් ඉතින් එහෙම ගන්න. එහෙම වෙන්නේ නැහැ. ඉතින් මෙතන තියෙන එක අනිවාර්යෙන් මේ දෙකෙන් එකකට කියවන්න නේද? වෙන කිසිම එකක් හිට ගන්න බෑ. හරිනේ? අර කියන්නේ 30 කියවන්නේ නැහැ නේ. ඒතකොට ඉතින් දැන් මෙතන මැද්දේ තියෙන එක either 23 or 24. Right? මෙහෙම එකක් කියවන්නේ නැහැ නේ. ඒතර දෙකයි තියෙන්න පුළුවන්. Right? It is either 23 or 24. So error is going to be only 1 millimeter. That is equivalent to least count. Case. Error is always equivalent to least count of the instrument. Right? This is actually called the maximum error. So the minimum reading is 23 millimeters. Maximum reading is 24 millimeters. Therefore, maximum error is 1 millimeter. That is exactly equivalent to least count. Right? Prove. Okay, now the error due to the measuring instrument is 0.5 millimeters, which means least count of this particular instrument is 0.5 millimeters. Right? That's a takeout you should take from the question, from the data given. The measuring length has to be greater than. Right? Tell me, what is the equation of percentage error? Equation of percentage error. Least count over reading into 100%. Right? Least count over reading is called fractional error. Right? Into 100% percentage error. Right? Length is the reading. So minimum percentage error is 1. Least count is 0.5. Right? Reading, let's say R into 100%. Okay, subject R is 50 millimeters. 50 millimeters. Answers are given in centimeters, which means 5 centimeters. 3. So first one, what was it? 5. 5, 2, 3. Right. Any questions? Master, okay, good. Okay. Next. Right. So by the way, what's the least count of standard vernier caliper we are using? 0.1 millimeters. Micrometer screw gauge 0.01. Spirometer 0.01. Same. Traveling microscope same 0.01. Right? 3. Sound does not undergo. I think we discussed the similar question in the last or before the last. What is it? Polarization. Because sound is a longitudinal wave. Sound is a longitudinal wave. Longitudinal waves cannot be polarized. Right? Sound does not undergo polarization. All other 4 can be done. Right? Reflection, diffraction, interference, and diffraction is possible. Right? Polarization cannot be done with that property of rarefactions and compressions. Right? Dimensions of frequencies. What is frequency? What is frequency? No, as an introduction or as a definition, what is frequency? Sorry? Number of oscillations per second, correct. Number of oscillations per second, right? Or number of vibrations per second. So that's a per second value. A number per second. Number per second, which means now we know this is measured in hertz. Actually, hertz means 1 over seconds. Hertz means 1 over seconds, right? S minus 1, right? No need to find anything. S minus 1 means the dimension should be T minus 1, right? Very straightforward. T minus 1, 4. Five. Okay, 5. Variation of the displacement x with time t for a particle executing a simple harmonic motion over a period of t is shown in figure A. Right. The variation of potential energy K of the particle, it should be. Question impact K of the particle with the time t over the period is best represented by, right? Elastic potential energy. What is the equation of elastic potential energy? Potential energy means elastic potential energy in a simple harmonic motion. What is the equation? Equation of elastic potential energy. Elastic potential energy. What is the equation? Half kx squared. right? Half kx squared. Okay, what is x? Displacement measured from center. Displacement measured from center, right? What is the displacement at center? 0. Then what is the elastic potential energy at center? 0. What is the displacement at amplitude? A. Amplitude. Amplitude means it's A. Amplitude. Then elastic potential energy at amplitude is maximum half k A squared, right? Okay, just by checking those things, right? First, I'm going to remove some graphs. So before all, now this is an energy. Is it a vector or a scalar? Energy. Vector or a scalar? Scalar. Scalars don't have a direction. Then they don't have a signage. Minus signs, nah. They don't have a signage. So therefore, at once, without doing anything, answer 4 is eliminated. Answer 4 is eliminated. Okay, then check it out. Displacement time is given, right? At t equals 0, check with me. At t equals 0, displacement is 0. Then if displacement is 0, elastic potential energy should also be 0, right? So it should be a graph starting from 0. 1 is wrong, 2 is wrong. Only 3 and 4 remaining now. Sorry, only 3 and only 3. It's only 3. 3 තමයි ඉතින්. නිකම්ම ගන්න පුළුවන්. Right? Since energy is a scalar, without doing anything, remove all the negative values because there's no signage for energy if there is a scalar. Since there is a scalar, right? Very straightforward. 4. Then answer 3, right? For 5, answer 3. 6. When a tuning fork A of frequency 100 Hz is sounded with a tuning fork B, the number of beats per second is 2. What is beats? Beats. We have met before, right? Last paper get the What is beats? What is beats? Sorry? Difference of frequency, right? Beats means difference of frequency. Then when a tuning fork A of frequency 100. 6. Tuning fork A of frequency 100 is sounded with B, right? Always you will have two options when you are doing a beats question, right? Now B can either be 102 or can still be 98 as well. We don't know what is higher and what is lower, right? Without knowing that, you can't decide anything. So always we have two options, right? Then on putting some wax on prongs of B, okay, applying wax. Putting wax means, what about the mass of the prong, mass of the tuning fork, increasing or decreasing when applying wax? Mass increases. Wax, no? Wax no? Mass increases. When mass increases, frequency decreases. Oh, last year, okay. Always frequency and mass are two inverse quantities. Frequency and mass are two inverse quantities, right? So when wax is applied, mass increases by a bit, right? Therefore, frequency decreases by a bit, right? Okay, so if it was 102, look at the board. If it was 102, we don't know what B is yet. If it was 102, it should be decreasing as this, right? If it was 98, it should be decreasing as this, right? And it says number of beats per second becomes 1 when wax is applied, right? Now, if it was this, what happens when decreasing? The gap increases 1 by 1. Initially, it was 2, but if it is decreased to 97, the gap is 3, right? Then gap is 4, gap increases, which means this is not going to be the case because number of beats is reduced to 1. Number of beats is reduced to 1, right? So therefore, should be this. Then after wax is applied, it should be 101. Then before wax is applied, it should be 102. Then the frequency of tuning fork B is, frequency of B means the original frequency, right? Then that is 102. 102, answer 5. So always you will have two options in a beats question, right? You have to pick the correct one based on the given data and the arguments. You have to pick the correct one, right? Any questions? Correct? Right. Okay, 7. Now in this paper, actually I didn't send you at the beginning. In this paper, I have included questions up to thermal physics. Thermal first part questions right? Next one, thermal question now. Thermal questions right? Because now you are going to have your next term test soon, right? Have you already had known? Right? December, first week, second week, December second week, right? So therefore, during this month, I'll include questions up to thermal, optics anyway there, right? Up to thermal, then if you haven't done thermal, that's just fine. Learn those parts here with the discussions, right? Because if you are going to have thermal physics in your term test, this should be a support for such ones, right? So that's why I have added questions key back at the right? This from thermometry. Anyone who has started thermometry, thermal physics? Optics. Now you said you are doing optical instruments. Optical instruments here, right? Where in optics? Prisms. Oh. Right. All right. The thermometric substance used in thermometer must. Right. Listen. Thermometric substance means, listen. So in thermometers, we have to have a substance which changes with temperature. Then only we can measure temperature. Now, as an example, if I explain using the most common thermometer, you all know mercury in glass thermometer. No? In mercury in glass thermometer, we have mercury. Mercury changes length of mercury column with temperature, right? Mercury is called the thermometric substance. If there is a substance which changes one of the properties of the substance with temperature, that is called a thermometric substance, right? Property change measure. When this is heated, if this doesn't change any properties, we can't use this as to measure temperature, right? If velocity, if volume changes, if length changes, if area changes, or some other physical quantity changes, then we can calibrate it and use it as a thermometer, right? So from the most popular one, mercury in glass thermometer, mercury is the thermometric substance, right? And the expansion of length is called the thermometric property. The exact property which is going to change with heat, with the temperature, is called the thermometric property, right? Thermometric substance and thermometric property, right? So thermometric substance is the substance, mercury. Thermometric property is it changes length, no? So that is the linear expansion of mercury. So thermometric property is linear expansion, right? Question is about thermometric substance used in a thermometer must. Okay, remain a liquid over entire range of temperature to be measured. No, it remains a liquid in some thermometers. There are thermometers using gas mediums as well. Gas thermometers are there, right? So therefore, it is not a must. Gas thermometers are solid. Next one. Have a property whose value increases linearly with temperature. Increase it should change. I told you it should change, not increasing or decreasing. Decrease it should change, right? Property should be changed. So we can't say increases, it should change. Third one, have a property that varies with temperature. That's the exact definition, right? If that doesn't change with the temperature, that is not a thermometric substance by definition. Thermometric means changes with temperature, right? Okay, 3 is correct. 4 obeys Boyle's law. That is only for gases. That's a special scenario, not a general one. Have a constant expansivity? No. Right, answer is 3. Answer is 3. Right. So since this is a new question or new part for most of you, take this down. Write down thermometric property. Write down thermometric property. Thermometric property. sorry, before that, thermometric substance. Substance. Thermometric substance. First write down thermometric substance. Okay, with a dash, write down any substance which changes, one of its properties. Any substance which changes one of its properties with temperature. Next, thermometric property. Property of thermometric substance. Did you miss it? My word. That means wrong. Okay, what did I say? The property of thermometric substance which changes with temperature. Okay, if you need examples, mention the example with the mercury in glass thermometer. If you need an example, right? So there are 6 main thermometers we are discussing in thermal, right? One is mercury in glass, right? In mercury in glass thermometer, thermometric substance is mercury, and thermometric property is linear expansivity, right? 8. What happened? 8 harder. Marker ever? What 8 gonna? Discount that now? Discount. Yeah, I got it. Then for 7, answer 3. 8. The length of a rectangular wooden block W is measured using vernier calipers. The figure shows the relevant sections of the vernier calipers and the block. Only relevant divisions in the vernier scale are shown. If there is no zero error in the vernier caliper, then the least count and the length of the wooden block respectively are. Right. Least count can be written as 1 division of main scale over number of vernier scale divisions. Right. Least count is 1 division of main scale over number of vernier scale divisions. Main scale is in centimeters. Then 1 division of main scale is 1 millimeter, because between 1 and 2 there are 10 divisions. Right. So 1 division of main scale is 1 millimeter. Right. Number of vernier scale divisions 20. 1 over 20. 1 over 20 is 0.05 millimeters. Least count is 0.05 millimeters. Now answers are given in centimeters. Then it should be 0.005 centimeters. If we need it in centimeters. Then the reading. And length of the wooden block. Is reading. Reading of any instrument which uses a vernier scale is given as the addition of main scale reading and vernier scale reading. Right? Main scale is completed main scale before vernier 0. Right? Main scale is completed main scale before vernier 0. Vernier 0 starts at 1 means 10, no? Then 11, 12, 13. 13, 14. 14 divisions are completed, right? Alright. 14 divisions are completed. Then 14 millimeters from main scale. Right? Vernier scale is read as number of coincided divisions times least count. Vernier scale is read as number of coincided divisions. Times least count. Right. Now, if your least count went wrong, definitely the reading would be wrong. Right. Coincided divisions. 10. 10. 8. Shifted. It's 10, right? Adi je moga guess hai. Right. So in millimeters, this is 0.05. 0.05. Right. 14. 14 plus this is 0.5. 0.5 millimeters. So final answer 0.50 millimeters. 14.50 millimeters. Centimeters right. Then 1.45 centimeters. 1.45 centimeters. 0.005 centimeters and 1.45. 3, right? Answer 3. Nine. What is it? Right out. 9. An object lies on a horizontal table. So if any questions, please raise. I'm quickly going through because there were no any much thinking parts in these first questions. So. Right. 9. An object lies on a horizontal table. When the object is pulled by a horizontal force F that increases uniformly from 0, the variation of frictional force F acting on the object is best represented by the graph. Okay. Now, first thing is this. Before explaining the graph, this is a graph that we discuss in theories. Right? First thing, you should know this graph. Right? You should know. There are two graphs we basically discuss under theories of friction. Right? Two graphs here. This is one of the graphs. Variation of frictional force with applied force. This is called the variation of frictional force with applied force. Right? I explain graph. This is a frictional force. This is applied force. Right? This is relevant to this kind of a scenario. Horizontal F and the frictional force is opposite for this kind of a scenario. Right? So until the object starts the motion, frictional force is self-adjusting. Right? About self-adjusting property, I think we met in one of the questions, isn't it? No? You have tried? Until the motion starts the motion, until the object starts the motion, it is self-adjusting, right? So if you apply, let's say 1 Newton, friction force will also be adjusted to 1 Newton. If there is 1.5, frictional force is also 1.5. So likewise, it increases up to what we call this point, maximum point, limiting friction, limiting point, right? So this is exactly a 45 degrees line, right? Mega y equals x graph and then because self-adjusting means f equals f, right? Y equals x, 45 degrees 45 degrees, right? And this maximum possible friction is called the limiting friction. Limiting friction. And when it comes to dynamic friction is also called kinetic friction, right? If the object starts motion, friction will be changing from static friction to dynamic friction. Dynamic friction is a constant. Right? Therefore, this will be a constant hereafter, and there is something like this. For static friction, there is a static mu s. For dynamic friction, there is a dynamic mu d. Always mu s is greater than mu d. That's a proved result. Mu s, static friction between any two surfaces is greater than dynamic coefficient of friction between the same two surfaces. Right? That we can feel if you are trying to drag something or push something, right? To start motion, we have to apply more force. But once it is moving, once you start moving motion, we can easily keep continuing the motion. Right? That is because of this friction decreases. Right? Right? So if we need to push this, just to start the motion of the table, we have to apply more force compared to the force you need to apply once it starts the motion. Right? So therefore, this is less. Something like this. This is the same graph that we taught under theory. So you should know this graph, right? About this. And here, now if there's anyone who don't know this thing, I'm recalling here. So up to here, this is called static friction. Up to here, there is static friction. After here, that is called dynamic friction. Static and dynamic. Maximum friction is limiting friction. Using F equals mu r, you can only find limiting friction, right? If the friction is between self-adjustment region, you can't use any equations, right? Because we don't need any equations. Because if the applied force is known, right, friction is always equal to the applied force in the self-adjustment region. So therefore, F equals mu r is only for the limiting point, right? For dynamic friction, that is a constant value. If mu d is known, dynamic mu is known, then you can find dynamic friction, right? So there are only two values that we can find on this graph using the equation. No? Using the equation F equals mu r. It's either limiting friction. If mu s is applied in the equation, limiting friction comes. If mu d is applied in the equation, dynamic friction comes, right? You can't do anything for this region with the equation, right? Okay, is it clear? Now, as an example, let's say this object is 5 kilograms, right? And I have given this mu s. I have given this mu s as, let's say 103, right? Now, if you apply this in the equation, 1/3 times 50, right? 1/2 kilogram, say half, 1/2 times 50, you get 25 newtons. This 25 is the limiting value, limiting friction, right? Now, let's say I say the applied force is 10 newtons. Then what is the frictional force? 10 newtons. Frictional force is also 10, because this is the limiting point. If applied force is less than limiting point, limiting friction, which means the object is inside self-adjustment region. Static means that is self-adjustment region. Therefore, frictional force will be self-adjusted as it is to match with the applied force, right? That is what is happening. Got it? An example is this. See, this is on this surface. This is on this surface, right? Now, if this surface is exactly horizontal, what is the frictional force? What is the value of frictional force acting on this object? This surface is exactly horizontal. Assume this as exactly horizontal, right? What is the value of frictional force applied on the surface? What about online students? Respond here. What is the value? Good. 0, it's 0, right? The reason is frictional force is the force which is counteracting the moving tendency. Motion or moving tendency. Now, if there is no moving tendency, there's no friction. Because friction is always to disturb the motion or disturb the moving tendency. Motion if there's a moving tendency also, friction comes to the play, right? Now, if there is no motion or no moving tendency, no friction, right? Now, I'm touching this like this. Say I have applied 1 newtons. What's the frictional force from? What's the frictional force now? 1, right? And I'm increasing this to 2 newtons. Still it is static, which means frictional force is also 2, right? Now, if I increase to 3 newtons, still this is static. Then frictional force is adjusted to 3, right? Now, at one point, this will be sliding, right? So, which means that is where I have exceeded that limiting value, right? Now, without keeping horizontally like this, if I kept this like this, now what about the friction? Is it 0 or non-zero? 0 or non-zero? Non-zero, non-zero. Now, if this weight is mg and this angle is theta, what is the value of friction? Mg sin theta, right? They're not mg sin theta. Okay, that's the idea. Now, even though there is no motion, there is a moving tendency here with mg sin theta. That is called the moving tendency. That moving tendency is counteracted, disturbed by friction. Okay. Any questions? Board is blurry. Let me check. I'll check. Okay, and now for this one, answer is 3. For this one, answer is 3. For 9, answer 3. And the other graph that we draw in theories in friction is this, right? Something additional, but we have only 2 graphs. I mean, 2 graphs that we discussed under theories, right? This is one. So definitely, you should know this. You should be able to recall this. and the next graph is this variation of frictional force with angle. Right, this is the next graph, variation of frictional force with angle. This is the next graph, variation of frictional force with theta, with angle. Right, what's the graph? Any idea about this? In the theory class I have discussed. Right, මේක තියෙනවා මේක අපි discuss කරන්න ඕනේ. හරි මම මේක prove කරන්න එක දැන් නැතුව graph එක ඇඳලා පෙන්නන්නම්. proof එකක් තියෙනවා. proof එකක් තියෙනවා. මෙන්න මේ graph එකක් එනවා. අද දිනන? දන්නවනේ? දන්නද? ඉස්කෝලේ ගියේ නෑ. ඉස්කෝලේ මේක හරි ගියා? ඔක කරලා නැද්ද? Which question? 9. It's 9. 9. හරි මේක දන්නේ නැත්නම් මම prove කරලා වෙන්නම් නම් මේ මම ඒක දන්නවද කියලා. මේ graphs එකම අපි අඳිනවා. Okay මේක අඳින්නේ මෙහෙමයි. See until this object starts motion f equals mg sin theta, right? Right here. මේක අඳිනවා හදිසි අඳිනවා. Until object starts motion, right? Until object starts motion. Until object starts motion, f equals mg sin theta, right? So we know sign variations, right? Sign variation එක දන්නවනේ ඒක දන්න ඒක තමයි. maths අයපා bio maths එක. Okay, what about bio students? හරි කවන්නේ. This is the sign variation. මේවා basic theories huh? This is a sign variation. You know, varies between what are the minimum and maximum values? +1 and -1. Right? You know, the value is 90. 180 it goes. Right? That's a cost variation. Almost the same. One half is shifted. Right? Still between +1 and -1. Here 90 cos 90 is 0. Right. What are the variations there? Right. Both of you are doing bio? Me variations there are not? Alright, make a questions sir. Alright. If there is any variable which has a variable of theta as a trigonometric value of sin theta or cos theta, it follows that respective variation of these two, because sin theta varies in this sinusoidal form and cos theta also varies in this sinusoidal form, right? And for physics, right, the actual thing is shape for physics, knowing the variation only up to 90 is enough, right? 90 can make graph shape right? For physics maths I think 720 physics 90 right? Variation up to 90 is enough. That's enough. Basically, when sin theta increases from 0 to 1 between 0 and 90, cos theta decreases from 1 to 0 between 0 and 90. Right? If there is any variable which follows or which has a variable as theta, variable of theta, right, with a trigonometric ratio, that variation follows the variation of that respective trigonometric ratio. Got it? Am I winning? The Megan sin theta variation. See what happens here? Graphing case mg is a constant. Since mg is a constant, f is proportional to sin theta, no? Isn't it? F is proportional to sin theta. When theta changes, sin theta changes, and according to sin theta, f changes. So therefore, first half is going to be a sign variation. Sign part until object starts motion. Not up to 90. May echchara kallak naha. May ida podi kallak thiye. May 90 may object it's no more. It's falling down. Right? May thiyenne ida wada podi kallak. Hari මේක මේ flat වෙනකම් මම හදලා නැහැ හොඳ. මේ කියන්නේ මෙහෙම තියෙන්නේ. අන්න මෙහෙම එකක් තියෙනවා. ඊට වඩා කලින් කැලලක් තියෙනවා. right? Make a flat pelana, right? Then once the motion is started, right, you can apply this. This is mg cos theta, right? If the motion is started, we know you can use f equals ma downwards, right? Motion එක දැන් start කරන්න. හරි. නැත්නම් f equals mu r apply කරලා ගන්නත් පුළුවන්. මේ ඕන විදිහට මේ graph එකක් දෙන්න පුළුවන්. f equals mu r for dynamic friction. මේ මෙතනින් පස්සේ dynamic එක. For dynamic. Right? Say f is මේ තියෙන fs fd dynamic friction මේ mu එක ඒතකොට mu d නේ. And r is going to be mg cos theta. f equals ma දාලා මේක ගන්නත් පුළුවන්. r is mg cos theta, right? Mu d is a constant, mg is a constant, which means fd varies as cos theta. So next half is the cos variation, right? And this is the limiting point. This is a limiting friction. So that is how this variation comes. මේ දෙකම දැනන් ඉන්න ඕනේ. මේ දෙක proved variations දෙක. දෙකම දැනන් ඉන්න ඕනේ. Right? So mostly when questions are coming, then මේක තාම ඔය grade 12 paper එකක්නේ. grade 13 වගේ papers වලට එද්දී මේ graphs එකෙන් අහන්නේ නැහැ. You will be asked a modified question to think based on these two. Right? එහෙම cases අහනවා. ඒතර මේ දෙක අනිවාර්යෙන් දැනන් ඉන්න ඕනේ. මේක තමයි අපි prove කරන equations දෙක. Okay, if there's anything, take it down. If there's anything that you don't know, මේ part එක දන්නවා නම් අවුලක් නැහැ. හරි. friction එකේ 50% විතර දැන් ඔය මම ඔය question එකේ explain කරා. Around 50% of friction is explained here. Take it down. මොකද? ඒ drop එකක් එන්නේ අර mu d mu s drop එක. අයි mu s is greater than mu d. මෙතනින් පැන්න ගමන් මෙයා dynamic මම මාක් කරනවා. dynamic එකට යද්දි mu එක drop වෙනවා. mu එක drop වෙච්ච ගමන් f එක drop වෙනවා. Online students, give me 1 second, I am checking. Okay, what about now? Is it still the same online? Now okay. All right, good. Okay then. Yeah, listen. Listen. Yeah, someone asked about this drop here. Same reason. Reason for drop is the same reason. This part is static. This part is static, right? And this part of friction is dynamic. When friction shifts from static to dynamic, mu drops, right? Since mu drops, the value of friction drops. F equals mu r, right? Value of friction drops. ඒක තමයි මේ drop එක. That's the same drop here. මේ දෙකේම තියෙන මේ drop එක. මේ drop එක තියෙන්නේ මෙතන. Because mu s is greater than mu d. Clear? Right, next one. It's clear, right? Any questions? If there's anything, ask, right? Right. Because friction is a very unique force. මේ friction වගේ behave කරන වෙන forces මොකුත් නැහැ. Friction කියන්නේ මාර අමුතු force එකක්. ඇත්තටම. Friction is a very unique and a strange force. ඇත්තම කතාව ඒක strange force එකක්. Right? Friction is a very strange force and its behavior is very unique for the friction. There's no any other force which behaves as friction. Right? So if there's no moving tendency, no friction at all. But at the very point that we are applying a force here, when moving tendency comes, immediately friction comes. Right? So that's a strange force. Right? So if there's no impact on the system, no force moment, no motion on the system, no force on the system, there's no friction. Friction එක shape එකේ ඉන්නවා. නෑ වගේ. ඇත්තටම නෑ ඉතින් නෑ වගේම නෑ. But even if a touch comes, friction comes immediately. හරි මේ touch කරන point එකේදී friction එක ඇවිල්ලා ඉවරයි. හරි? මේ friction එක generate වෙන්නේ it takes milliseconds. එක milliseconds වත් යන්නේ නෑ. Immediately it generates. ඒක මාර force එකක්. Right? Again if this is removed, no friction again. Right? Something like that. Moving tendency එකක් තිබ්බොත් විතරයි friction එක එන්නේ. Correct? Okay. Next. Friction is a very unique force because of those behaviors. 10. Self-adjustment or self-adjustment එහෙම වෙන forces කාටවත් කරන්න බෑ. Only force a self-adjustment is possible is friction. Right? In the world, වෙන මොකුත් force එකක් නෑ self-adjustment කරන්න පුළුවන්. Right? Self-adjustment නෑ. We should adjust. Right? Friction එක අමුතු force එකක්. Okay, a circular hole is made of steel sheet of linear expansivity 1.5 times 10 to the minus 5 per degrees Celsius. Sheet is raised by 100 degrees Celsius. The area of the hole is, okay, thermal expansion. See, a hole is given here, right? Area of hole is, okay, linear expansion, right? Now, this is where the substance is. This is where the material substance is. Right. Now, when it comes to expansivity, there are three expansivities, three expansions a solid can do, a solid could do. Linear expansion, area expansion, and volume expansion. Right. All three equations goes together, very much similar. So, therefore, I'll write all three equations here. For delta L, linear expansion is given by L1 alpha theta. Area expansion delta A equals A1 beta theta. Volume expansion delta V equals V1 gamma theta. Right? Delta L, delta A, delta V are change of length, change of area, and change of volume. Because expansion is not just expanding, contracting is also expanding. Because if we cool a system, it contracts. Right? That is also a part of expansion. Right? If we heat a system, it expands. Right? But generally it's called expansion. Contraction is also an expansion. Right? And L1, A1, V1 are initial values. Initial length, initial area, initial volume. Right? And for the material, for the substance, there's a property, a constant, or the coefficient, which determines the amount of expansion. Right? For linear expansion, this is called coefficient of linear expansivity. This is called coefficient of area expansivity. This is called coefficient of volume expansivity. Theta in all equations is temperature difference. Right? Temperature difference. Only equation එක බලලා apply කරන්න තියෙනවා. Right? And one more thing, between alpha, beta and gamma, right? For a solid medium, beta equals 2 alpha and gamma equals 3 alpha. For a solid. Right? That's all. Right? So just learn this today. Yeah? පොඩි කෑල්ල. මලවල ඉස්සරහට එනවා. Right? Now, once you learn this here, right? Again, if you are doing thermal in the theories, you will understand it better. Right? Now, always that is how humans' brain work. If we know something already, we will understand it better rather than hearing it for the first time. එහෙමත් තියෙනවා. දැන් මම මේ අද කියන ටික ආයේ අනිත් next week එකේ කිව්වොත් you will understand better. Something like that. අදවා movie එකක් බලනවා. Just an example lah, movies බලන්න එපා. අදවා movie එකක් බලනවා. නැත්තම් කියලා movies බලලා. Right? You are watching a movie today. Right? Say a detective one, මොකක් action or detective මොකක් හරි මොකක් එකක් බලනවා. අර නිකන් මල් කතා නෙමෙයි. මොකක් හරි detective එකක් බලනවා. අර වෙයි ඉතින් තේරෙන්න මොකුත් එකක් නෑනේ. A detective story. Right? When you are watching the movie or TV series, movie for the first time, right? Now you are thinking that you have understood the story and you know the story. Watch it for the second time, then you will understand it better by seeing all other small hints, the minor hints that is given in the movie. අපිට ඒක first time පේන්නේ නැහැ. ඊට පස්සේ අර story එක දැනගෙන බලන්නේ. දැනගෙන බලද්දි මෙතන මෙහෙම hint එකක් තිබ්බ, මෙතන මෙහෙම hint එකක් තිබ්බ. Even if you are playing a game also that's same. මම නිකන් පොඩි examples කියන්නේ. You are playing a video game for the first time, right? සමහරවිට mission එක complete කරලා ඉවරයි. එච්චරයි. Complete the same mission for the second time or third time, then you will understand the other things better. සමහරවිට දැන් අපේ කාලේ නම් අපි IGI එහෙම ඔය එන්න viral නේ. ඉතින් IGI 10 පාරක් විතර ගහද්දී අර කලින් 9 පාරම දැකපු නැති තව පොඩි small මේ ඒ කියන්නේ maybe ammunition or something like that. එහෙම තියෙනවා. ඒක අපිට first time පේන්නේ නැහැ. එහෙම තමයි humans brain වැඩ කරන්නේ. ඒකම තමයි මේ learning වලට applicable වෙන්නේ. If you are learning something for the first time, you will understand something out of it. Now, if I am saying 100 words, right? Say as a percentage, you are understanding 20%, right? Now, if you do the same for the second time, right? Medica, you are go through karagyanno, you will understand it better. For the third time, even better, right? That is how it works, right? Then මේක දන්න තුනට කවන්නේ මේකෙන් ගාන හදන්න. Then once you do this in the theory class, right? You will understand this better. Because always we will understand known things better rather than hearing it for the first time. Right? Okay. Area of hole is increased by, okay, increasing or decreasing. Temperature is raised by 100. No, this is like this. If temperature increases, it is expanding. If temperature decreases, it is contracting. Right? So decrease කියන answer sign කළා. Because it is not going to decrease, it is going to increase. Right? Not the hole is going to increase, but the material here. So therefore, eventually, hole also increases. Like a hole එකක් නේ. I'm going to use the equation for the material, substance. Substance එක තමයි increase වෙන්නේ. Once the substance increases, hole automatically increases. Substance එක expand වෙනවා. ඒතර the hole එක expand වෙන්න ඕනනේ. Correct? Then delta area එක ගහලා තියෙන මේ equation එක දානවා. We need delta A. Delta A is A1, initial area. මේ fraction එක ගහලා තියෙනවා. Fraction of increment is this. Delta A over A1. Right? Fraction of increment. Delta A over A1. Fraction with respect to initial area. Right? That is beta theta. මේක එන්නේ කෙලින්ම beta theta. Beta is not given. Rather, linear expansivity is given. But beta is 2 alpha. Then 2 times alpha 1.5 times 10 to the power minus 5. Theta is 100. Right? So this is 3 times 10 to the power minus 3. Increase by 3 times 10 to the power minus 3, answer 1. Increase by 10 to the power 3 times 10 to the power minus 3, answer 1. We have a video game ගන්නවා. Video game කියනවාද? Computer games ගන්නවා. ගන්නවා. මේක තමයි මට මෙයාත් ගන්න. it's better if you can stop until the exam. ඊට පස්සේ නම් ඕන තරම් play කරන්න. I also have played video games from grade like 6 to 9 full time. එච්චරයි. ඊට පස්සේ වැඩි ඉවරයි. ඊට පස්සේ hobby එකත් ඉවරයි. එහෙම තමයි ඉතින්. Hobby should update and upgrade. ඔවත් update වෙනවා. තාම සමහරවල් play කරනවා. මගේ not as a hobby. right PUBG එහෙමත් මම play කරලා තියෙනවා campus එකේ ඉන්නකොට කට්ටිය set ලා ගහනවා. hobby එකක් නෙමෙයි. set වුණොත් ගහනවා. එහෙම. finish. Okay. Next 10 questions. So if there's any questions regarding first 10 questions, any doubts about first 10 questions, you can ask. Right? You can ask if there's anything. Okay. Next 10 questions. Right. It's 8:50 now. So I'll be giving you time from 8:50 to 9:05, 15 minutes. 9:05. Try 11 to 20. Try 11 to 20. Huh? 7. Okay. Question 14, it should be corrected as question 14. It says which of the following graphs best represents the variation of volume V of a fixed mass? Of a fixed mass. Of a fixed mass of an ideal gas at constant pressure, which is absolute with this its absolute temperature, right? Question 18. Question 18. It says the relationship between speed, frequency, and wavelength of a wave is given by. It should be V equals F lambda. Given by V equals F lambda. Consider the following statements about this relation, right? V equals F lambda, right? F lambda in patra mark karila. Right? It should be V equals F lambda. Question 20. Question 20. In answers, all answers should be false. Only A is false. Only B is false. Only A and B are false. Only B and C are false. All A, B, C are false. All should be false. Right? False karagan. Answers. Question 20. Answers in question 20. Make them all false. Make them all false. In 10th question, how 2 came? What is 10th question? No, 1 came. 1. I said 1, right? 1? It's not 2. You are asking about this 2. That is because of this. Beta equals 2 alpha. Beta equals 2 alpha. Alpha is linear expansivity, beta is area expansivity. Okay. Right. Let's see. Okay. Eleven. 11. Which of the following distance time graph is not possible? Not possible. What have you chosen? What have you chosen as answer? Huh? 3, 2, 4. 4. What about you? 2. You know it? 4, 5. 5. What about online? Make a simple question now. Body logic kya तीन? Body logic kya तीन? वहाँ के answers है. What about online? What are the answers? What are the answers you have chosen? 5. 5. What's the logic behind 5? If that is not possible, what's the logic? What's the logic? It's decreasing distance with time, over time. Decreasing distance over time. So what's the logic of being impossible? What's the logic? Maka logic क्या तीन? Logic क्या तीन? What's the logic? Samjit. Advena koda? Udo. Return motion. You are plotting the graph from, let's say, here to here. Paragraph again. You are plotting a graph of this object from here to here. 5 in, isn't it? 5 in. There are 5 in. Something like this. Displacement graph anything? මෙහෙම එක්කුත් නෙමෙයි අතරම දැන් මේක නම් ඇක්සලරේට් වෙනවා. ඇක්සලරේට් වෙන්නේ නැහැ කියලා හිතන්න. ඒක ඇක්සලරේට් වුණොත් එහෙම මෙහෙම එන්නේ. Linear නම් say this object starts a motion from here and coming down with a uniform velocity. Answer is 5. Body logic क्या තියෙන්නේ? Impossible one is 3. 3. What's the logic? අන්න හරි. ඒක තමයි logic. That's the exact logic. There is a non-zero displacement in that graph with a zero time. Cannot be. Cannot be. This is the case. See, this is possible. No? This is possible. There can be a time without having any displacement. That is fine. The object is at rest, right? But this is impossible. Compare with this one. But this is impossible. There is a zero time given there with a non-zero displacement. If a displacement is made, there should be a time spent. Right? If a displacement is made, there should be a time spent. Right? That's a mistake. That's the point that is being impossible. Right? Got it? Logic. මේකට තව logic එකක් තියෙනවා. Maths කරන්න ඕනෙත් නැහැ. What is represented by gradient of S3? What is represented by gradient of S3? Gradient of S3. Huh? Grade 8, 9, 10 before O levels. Velocity, right? Velocity. Gradient is either tan theta or delta y or delta x. See? on the logic क्या තියෙනවා? Gradient is either tan theta or delta y or delta x. Right. What is the gradient of a vertical line? What can you say about the gradient of a vertical line? Huh? What's theta of a vertical line? What is theta of a vertical line? 90, right? Then m is tan 90. What's the value? Infinity, not defined. Not defined. So there cannot be a motion. A mathematical approach, right? Not defined. Infinity is not defined, right? ST curve again vertical lines here and there. There are no vertical lines at all because it makes velocity infinite. Infinite velocity means not defined, no motion. Cannot be. Impossible. Right? Impossible කියලා මහල් දෙනවා. Not possible. Right? Mathematical approach එකක් තියෙනවා. Mathematical approach එකක් නැත්තම් basically මේ මෙහෙම හිතන්න පුළුවන්. මේක ඕනේ නැහැ. This is something additional. Right? This is something additional because we know gradient is velocity. Right? අපි දන්නවා gradient types දන්නවා. Gradient of a vertical line we know that as infinity. Right? So therefore this is also possible. Right? But without thinking of anything, we can just practically think whether there can be a non-zero displacement at a zero time interval. No. Right? If something displaces, say 1 centimeter displaces, it takes a time. Time එක යන්න නැතුව teleport වෙන්න බෑනේ. එහෙනම් teleport වෙන්න ඕනේ. Right? එහෙම බෑ. Okay, 12. Is it clear? A simple logic. Right? So අනිත් graphs වල මොනවා හරි issues තියෙනවද කියන්න. Right? 5 එක හරිනේ. 5 is a correct graph. හරි අනිත් ඒවා issues නැහැ. And 4 is an object which is moving with an acceleration. Right? Because increasing gradient is an increasing velocity. So that is an accelerating body. So again accelerating body එකක් වෙති. 2 is at rest. Right? 2 is at rest. 1 is an object moves with a uniform velocity. Because uniform gradient, that's a constant gradient. That's an object moves with a uniform velocity. Right? එහෙම වාට නිකන් define කරගන්න පුළුවන්ද කියලා බලන්න motion එක. Whether you can explain the motion. If that is explanatory, which means that should be a possible motion. No? Explain කරන්න පුළුවන් නෝ. Right? එහෙම බලන්න තිබ්බා. මේක explain කරන්න බෑ. Without going any time, there is a non-zero displacement. Okay, 12. The speed of sound in air at 20 degrees Celsius and 36 centimeters of mercury is 330. The speed of sound in air at 35 degrees Celsius and 35 centimeters of mercury will be. Right. What is the velocity of sound velocity? Sound velocity, or just tell me what is the velocity of a wave in an air medium? What is the general equation for velocity of a wave in an air medium? We have actually two equations. What are the equations? What are the equations? Waves? No, that's liquids. That is for liquids. What are the equations? Either gamma RT or M. කලිනුත් මේවා use කරා. Or gamma P over O. ඇයි මම මේක use කරලා පෙන්නුවේ මේ මොකද පෙන්නුවේ? මම මේක proof එකක් කරලා පෙන්නුවා මේක use කරලා. What was that? මට හදයි. මොකද කරේ? මේක මම use කරලා proof එකක් කරා. In one of the previous papers. What was it? මතක තියෙන්න ඕනේ. Okay, tell me, what are the dependents of sound velocity through air? What are the dependents of sound velocity through air? Equation එක දිහා බලලා කියන්නේ. What are the dependents? Absolute temperature, molar mass, right? Gamma constant, gamma is Cp over Cv constant, R is a constant. What about P? No. මම නෝක prove කරා. I proved. Even though P is there in the equation, just by changing pressure of the gas, it is not going to change sound velocity through air or velocity of wave through air. Because when P changes, rho also changes. I used the equation Pm equals rho RT, or rather Pm equals dRT, and proved this. Right? Mata තියෙනවා. I think before 2 weeks. Last week then. ඒක මත ඒක නේද? Last week. Last week. මට මතක නැහැ. මට මතක නැහැ මට ප්‍රූව් කරාගෙන මතකයි. Last week. Yeah, probably it might be the last week. Oh, day before the last week because we had a MCQ discussion in the third week. ගොඩක් වෙලාවට MCQ එක හම්බුණා වෙන්නේ නැතේ කොහොමද මම මේක ප්‍රූව් කරා. Right? Even though P is a variable in this equation, just by changing pressure, sound velocity through air cannot be changed because with the same ratio, rho also changes. Right? මතක තියාගන්න ඕනේ. Because PM equals මම දැන් ආයෙ මේක prove කරන්න ඕනේ. PM equals rho RT. Right? If RT are constants and if M is a constant, when P changes, rho automatically changes. Right? When P changes, rho changes, and it counterbalances this ratio. It balances the ratio. Right? Okay. Then if you are choosing this equation, you have to know pressure and density. Right? Density is not given in the medium. Medium of density is not density of the medium is not given. Right? Even though the pressure can be written using the mercury column. Mercury column में pressure के लिए as HROG. Right? So therefore, you are restricted to use this equation. You are restricted to use the equation. Go with the first one. Right? Now, before applying the equation, if you can see constants, you better cut them off first. Gamma is a constant, R is a constant, M is a constant. Right? Same gas, no? Same air medium, same gas. Right? So, what remains is, if constants are cut off, proportional sign remains, P proportional to T. Right? Apply this for these two scenarios given. The speed of sound in air at 20 is 330. Right? 330 proportional to 20 means 293. 293. Arne? Absolute temperature. Absolute temperature. Absolute temperature. Right? ICT करना है ना? How to find absolute temperature? How to find absolute temperature? What ICT? ये क्या है ना? ये मिशिगन के निकल मेगा हाथ लग जाना तो जानो ने? I discuss the same type in previous ones as well. At 273. करना दे. Oral से लगती ना तो कोई मान दाना. Like this. These only for IT students. Kelvin temperature is Celsius temperature plus 273. Yeah. Right. Then the speed of sound in sound in air at 35 degrees Celsius and 75 centimeters of mercury will be. Right. V at 35. 35 again here. 308. Is it? 308. Right. Divide these two. Right. You can divide divide these two. That's it. V will be 330 times. Divide these two. 308 over 293. Is it? Arre, make a divide कर देने. For 11, what was the answer? Well, this one 5. What are you doing? Okay, any questions? Any questions? Any questions? मैं आगे है तो ना मैं आगे है तो ना फिजिक्स में है What is it? Total. 13. 13. A normal eyeball has a diameter of 2 centimeters as shown in the figure. Right. Eyeball කියන එක දන්නවනේ. Usually our eyeball is in the range between 2 to 2.5 centimeters. Right. දන්න බයෝ ගන්නවනේ ඔයගොල්ලෝ. ඒ වගේනේ. Usually ඔක තමයි range එක. 2 to 2.5 වගේ තමයි මේ අපේ eyeball එකේ range එක. Right? Usual range. The magnitude of the maximum power of eye lens is least distance of distinction is 25. Okay, right. What is least distance of distinction? Now this is something from optics, right? So I told you last week that I'm including questions from optics in this paper. So they are from optics. What is least distance of distinction? We call capital D usually. We call capital D, right? In physics, we call capital D. Least distance of distinct vision. What is it? Any idea? IDFX kalate? Yeah. What is it? Minimum distance can be clearly seen. Can be clearly seen. No, there's another keyword missing. Can't I clearly see this? This is less than 25. Almost clear. Clear එකටත් වඩා හොඳ එක තමයි 25 means, so least distance of distinct vision means that is the minimum distance or the shortest distance we can see without paining our eye, without having any pain in the eye, right? So usually if this is less than 25, now still we can see, but try out and see, but our eye get some kind of a pain from these tissues මොනවා හරි තියෙනවනේ අන්න ඒවා පොඩි pain එකක් කරනවා මේ හැරේ focus කරන බලනවා this naturally not supposed to focus for a point less than 25. That's the reason, right? පොඩි pain එකක් එනවා, right? Minimum distance that we could see without having any pain, right, is 25. Otherwise it doesn't mean points before 25 or below 25 is not visible. It is visible, right? මේ ටික black වෙලා මෙතනින් එහාට පේන්නේ නැහැනේ. Visible, but the reason is when the eyeball tries to, or the eye lens tries to focus to points which are less than 25, it is getting painful, right? ඔතන තියෙන මොකද issue එකේ නම? ඒක තියෙනවා නම. මේ අපේ focal length එක වෙනස් වෙන issue එක මොකක්ද? issue එක හෝ මොකද ඒක කියන්නේ? No, iris නෙමෙයි tissue එක. Ciliary muscles, right? Ciliary muscles. අන්න ඒක තමයි. Ciliary muscles කියන එකෙන් තමයි adjust කරන්නේ. තේරුණාද බය? නැත්තම් වයින් ගහන්න නේද? Ciliary muscles, right? ඔය බයෝ කට්ටිය දන්නවා. මෙන්න මේ දෙපැත්තේ තියෙනවා, right? So by changing that, focal length of eye lens can be changed, right? From 25 to infinity, right? But if you try to focus to any point, listen, this is a new thing, right? If you try to focus to a point which is less than 25 also, what our eye tries is to focus here, but it is not made to focus to points less than 25, but it still tries. It tries. So when it tries, these ciliary muscles are fatigued. Like a fatigue will strain. Once it is strained, you will get eye defects sooner, right? So that is why it says it is not advised to watch screens much closer to the eye, because always the distance, further the distance we are looking at more resting the eye, so there's less pain to the eye, right? The least pain is when looking at where? The least pain for the eye is when looking at infinity, right? Maximum point that we could see is infinity, right? Least pain, minimum pain of the eye is when looking at infinity, right? That is considered as no pain at all. Therefore, that point is called rest in I. That is called rest in I. Rest in I is when looking at infinity. Right? Try out කළ බලන්න. අපි මේ ළඟ බලලා ඉඳලා එකපාර දුර බලලා බලන්නකො. මේකේ පොඩි තියෙන රිලැක්ස් එකක්. That is because of that. Right? අර ඩොක්ටර්ස්ලා කියන්නේ අහලා නැද්ද මේ now if you are doing studies for like 12 hours 18 hours a day, right? මේ 25 කරනවා 18 කරන ළමයි personally දන්නා ඉන්නවා normal ඉතින් මේ දවස්වල 18 කියන්නේ normal I'm honest totally normal 18 hours ඉතින් ඉතුරු 6 hours වල අනිත් වට ටික කරගන්නවා having like 3.5 to 4 hours of sleep and they balance somehow 18 hours වැඩ කරනවා මම personally දන්නා ඉන්නවා I'm serious දැන් ඉනා වුණාට ඕගොල්ලෝ බලන්නකෝ right I'm serious එහෙම තමයි ඉතින් කරන්න නැතිවත් ඉන්නවා ඉතින් මම ගැන කරන්න ඉන්නවා right so they will get their results corresponding to the amount of effort that they put that is how it is right මොනවාද රයිස් වපුරලා මේ අල ගන්න බෑනේ එහෙම තමයි okay ඒක වැඩක් නැහැ මේ ඒ වගේ කට්ටියට ඩොක්ටර්ස්ලා කියනවා මේ if you are keep looking at books or something like that for a longer period of time, right? They are advised to have the study table near a window. Haven't you heard about it? Near a window. Then easily they can look through the window once they need a rest. කියන්නේ ඇත්තම කියන්නේ 20 minutes වලට වඩා බලන්න එපා කියලා. ඇත්තම කතාව. Right? For each 20 minutes 23rd rule හරි ඔන්න මොකක් හරි rule එකක් තියෙනවා. හරි මම ඒක දන්නේ මේ ඩොක්ටර්ස්ලාගේ කේස් එක 23 rule hari 22 hari මොකක් හරි 22 hari මොනවද yeah 21 I guess for each 20 minutes we have to have a rest of 1 minute for the eye එකන eye එක strain වෙන්නේ නැති වෙන්නනවා හරි දැන් අපිට එහෙම rest ගන්න බෑනේ ඒතකොට අපේ eye එක strain වෙනවා but ඒක තමයි biologically කියන level එක මම rule එක හරියට මොනවා value එක හොයලා කියන්නම් මේ මාත් ඔක ડોක්ටර් කෙනෙක් කිව්වේ ඒකයි ඒක logic එක කියලා 22 1 hari 22 2 hari මොකක් හරි ඔනම rule එකක් for each 20 minutes you have to get a rest ඕක තමයි ඔගේ basic idea එක right so rest කියලා කියන්නේ දැන් ගිහිල්ලා සෙල්ලම් කරලා එන්නේ නෙමෙයි you have to keep the book aside and look through the window somewhere that is a little bit far away right අන්න එහෙම තැනක තමයි ඉන්නේ කියලා කියන්නේ ඒකත් ඔය green වගේ colors eye එකට ගොඩක් අර මේ what we call it's more relaxing ඒතකොට green වගේ බලන්න පුළුවන් නම් තවත් හොඳයි කියලා කියනවා right hari පාඩමට ඕන එක මෙච්චරයි the rest in eye is when we are looking at infinity right so if you are observing if you are doing stargazing or something like that right we have resting eyes right ඒක තමයි හොඳම කේස් එක stargazing කරලා බලන්න rest in eye එකටම යනවා right ඒතර මාරාතල ඒ කියන්නේ ඒක eye එක adjust වෙන්නත් යනවා මේ colors වලට around 10 minutes right now if you just look at the sky you will see all stars in a yellowish color but there are stars in bluish colors violet reddish colors brownish yellowish ඔය ඔක්කොම තියෙනවා ඒ ටික separate වෙන්නේ විනාඩි සාමාන්‍ය 15ක් විතර අපිට adapt වෙන්න around like 10 to 15 ඒ වගේ time එකක් යනවා මේ එතකොට rest in eye එකේ අපි ඉන්නේ right focal length එක වෙලම adjust වෙනවා but to adjust our eye to adapt our eye for the colors it takes some time right ඒ වෙලාවට කියන්නේ ඒක දිහා බලනකොම screen එකක් වගේ බලුවොත් ආයෙ ඒක reset වෙනවා something like that stargazing කරනවා නම් screens මොකුත් බලන්න නැතුව අර විතරක් බලන්න ඕන එහෙනම් පොඩි එකක් තියෙනවා ambient colors කියලා එකක් තියෙනවනේ ambient colors වලට අපේ eye එක adjust වෙනවා දන්නවද මේ මම මේ common sense එකක් කිව්වේ ambient colors කියලා එකක් තියෙනවා right with the temperature and the colors there's a variation in colors with the temperature that is called ambient coloring ඔය iPhone වල option එකක් තියෙන්නේ ambient true tone කියලා ඒ ambient එක ඒක temperature එකත් එක්ක තමයි වෙනස් කරන්නේ red එක මට 25 degree celsius වල පේන red නෙමෙයි same red එක මට 35 degree celsius වල පේන්නේ ඊට වඩා ඒක තව පොඩ්ඩක් අර orange side එකට යනවා ඒක තමයි difference එක but still if there is the same red I had color codes තියෙන්නේ same red I had even at 35 degree celsius also I should be able to see the true color no so that's why true tone is there in the display so automatically display එකෙන් ඒක adjust කරලා මට පෙන්නනවා අර තිබ්බ color එකට that's the theory behind it physics part behind it That's why two tone is two tone නැති display එකක් එක compare කරලා බලන්න. ඒක වැඩ කරන්නේ නැහැ. මේ color එක වෙනස් වෙන්නේ නැහැ. Okay, okay. Right. So when we are looking at infinity, that is called the rest in I. Right? මම මේ theory part එකට අග්ගාලා කියන්නේ. When we are looking at infinity, that is called the rest in I. Rest in I means there's no pain at all for the eye if you are looking at infinity. Right? Okay, now the question is about maximum power of eye lens. What is power of a lens? Power of a lens is defined as 1 over f. Power of a lens is defined as 1 over f. Right? And f should be measured in meters. This is a must. It is compulsory to measure in, should be measured in meters. It should be measured in meters. Right? Okay, now look at here. A very small thing. I explain some background about the question. See, higher the focal length, lower the power. Now it is about maximum power. Right? Maximum power is when minimum focal length. Right? Our visible range of human eye is from 25 to infinity. From 25 to infinity. Right? Another small thing like this. Say I have 3 lenses like this. 3 convex lenses. 3 convex lenses like this. Learn these things today itself, today onwards actually. 3 convex lenses, same height, only the thickness is different. Right? So what do you think having the maximum focal length is? What do you think having the maximum focal length is from these 3? Or is it same? Say f1, f2 and f3 focal length. What is the maximum? Not same. Thinner the lens, higher the focal length. The reason is focal length is associated with the curvature here. මේ මෙතන curve එකක් යනවානේ. මේ circle එකක් යනවානේ. Right? Focal length is associated with the circle here. Right? Thinner the lens, higher the circle. More larger the circle is. So higher the focal length. Right? So මේක එන්නේ මෙහෙමයි. Thinner the lens, higher the focal length. Right? මෙයාගේ circle එක පොඩි. මෙයාගේ පොඩි circle එකක් යන්නේ. Got it? These are complete theories in optics. We'll be doing these things again when we are doing these parts. Right? So just know these things from here. Then you know these things even before I discuss. That is better, no? Right? Just know them. Thinner the lens, higher the focal length. Right? Okay. Now tell me. Now I'm going to connect this with the scenario. If a person is looking at 25 near point, 25 is called near point. Infinity is far point. Right? If we are looking at 25 or infinity, our eye lens gets thinner. Thin වෙන්නේ කොහේ බලද්ද? Far. Right? Far. මේක open up වෙනවා. Right? When this is opening up, it gets thinner. Right? So therefore, when we look at far, right? මේ connect වෙන විදිය. When you look at far, far means infinity. Right? Our eye opens up. When eye opens up, it gets thinner. Right? It gets thinner. Right? ඒක thin වෙනවා. It gets thinner. Right? So therefore, when it is thinner, f increases. F is actually the maximum. Power is minimum. So therefore, this case is also called minimum power. This case is called minimum power when looking at far. Right? When we are looking at near, that is a maximum power. අපේ අය එක මේ වගේ එතකොට. හරි ඕක මේ සමහර පූසම් දෙම හොඳට පේනවා. හරි? ඒ කියන්නේ අපෙත් ඒක තේරෙනවා ඉතින් හොඳට අපි බලන්නේ නැහැ අපේ ඇස් එක දිහා. බලන්නේ නැහැ නේ. ඇස් එක දිහා බලන කර ඉන්නවද? අපි අපේ ඇස් එක දිහා බලන්නේ නැහැ නේද? මේක මම නම් පූසම් ගේම සෑහෙන ඒ කියන්නේ හොඳට බලන්න ඕනේ. හරි 25. Then maximum power is when this is 25. This should be substituted in meters 10 to the minus 2. 4 diopters. Sorry, diameter is 2 centimeters. Oh, you got it. Diameter is 2 centimeters. 2 times 10 to the minus 2. 2 times 10 to the minus 2. 100 over 2. 50 diopters. Right? Because when we are looking at near, this is how our eye works. When we are looking at near, right? Near means 25. This is 2. Huh? Oh, wait. Wait. See, F is not given. Diameter. I thought F is given. F name diameter. If diameter is given, diameter acts as the image distance. This is 2 image distance. We call V, and this is U. Object distance, that is 25. Lens formula. Applying the lens formula, and we have to find the focal length first. It has a focal length. Right? Only the diameter is given. When the image is formed at retina, when the image is formed at retina, this distance is equivalent to diameter of eyeball. So V is equivalent to diameter of eyeball. Right? Lens formula. This is called the lens formula. For any lens, this is applicable. For convex lenses, V is minus, right? V is minus, and there's a sign convention as to the same direction of light minus opposite direction of light plus, right? So therefore, V is minus, U is plus and minus is still minus. 1 over V plus 1 over U equals 1 over F. 1 over V is 1 over 2. 1 over 25 equals 1 over F. What is F here? Common denominator is 50, right? 50 measuring 25. 25 plus 2 equals 1 over F. F is 50 over 27. Correct? F is 50 over 27. Right? Sorry about that. I thought it's the focal length given, only the diameter is given. Focal length this is how focal length is determined, 50 over 27. Now, if focal length is known, I'll be erasing this. Apply in the power equation. Apply in the power equation. Power is 1 over F, but F should be plugged in meters. This is called a power of a lens. Power of lens, P. 1 over F should be in meters, right? Now, F is 50 over 27, no? 50 over 27. This should be in meters. Then times 10 to the minus 2. Simplify this. 100 over 50 times 27. This times 2. 54 diopters. 54 dina? 54. Answer 4. Right? Make question parts. This is something additional. Make a infinity right? You have to make sure whether the eye is looking at infinity or 25. Right? Make QA. Right? When thickness changes, focal length changes. But specs okay. Higher the thickness of the glass we are wearing, which means lower the focal length. Right? Okay, we'll discuss those things in the theory parts. Okay, 14. Which of the following graphs best represents the variation of volume V of a fixed mass of an ideal gas at constant temperature with absolute temperature T? Constant pressure, right? It's called constant pressure at absolute temperature with absolute temperature. 14. Okay, that is a gas law we have. What is this gas law? If pressure is constant, what we call it? If pressure is constant, this is a particular gas law. What is it? Charles law, right? මේ A levels ඕනේ නැහැ මේකට. දන්නවද? boys වලට තියෙනවනේ Charles law. නැද්ද? boys වල තියෙනවනේ. නැද්ද? IT ගැන නම් දන්නවද? Okay, this is called Charles law. Charles law එකේ තියෙන මෙහෙම එකක්. V proportional to T. V proportional to T. ඔන්න මේක ලියන්න පුළුවන් V equals KT. Right? Now graphing P is at X. මේක තමයි X. Right? Whatever it is as a constant, as a product, a constant product, that is the gradient. This is Y. So graph is Y equals mx. Mx answer 4. For 14 answer 4. Right? Make a graph in, right? Physics වලින් තියෙන මේ part එක විතරයි. That is a Charles law. Even if you know PV equals nRT, it is still doable, right? ඔන්න ඒක අඳින්න පුළුවන්. Right? එහෙම කරලා අඳින්න පුළුවන්. That is fine. graph ඉන්නද? ඒක හොඳයි. හිතුවා කරේ මේක කිව්වා කියලා. hina වෙන්නේ ඉන්නේ. හරි. මේක බලන්න. Yeah. If there's anyone who still didn't know how to plot graphs, right? මම කලින් දවස් දෙකක් විතර කිව්වා, right? I have that free video, free seminar done. The seminar conducted about graph plotting. Right? අන්න එක බලන්න ඒකේ මේ ඔක්කොම තියෙනවා. Right? The techniques we are using when plotting graphs. Techniques තියෙනවා. Graphing කියන එක හිතලා කරන්න බෑ. ඒකට technique එකක් තියෙනවා. Right? එහෙම තමයි. දැන් physics වල techniques වෙනයි, maths වල techniques වෙනස්. Right? මේ මම කියන වීඩියෝ එකේ තියෙන්නේ that is the graph plotting techniques we have in A level physics. Right? For both maths and bio students. Right? නැත්නම් maths වල තව techniques ගොඩක් තියෙනවා. Okay, I'll be erasing this. Which of the following statements is not true for a mixture of ideal gases in a given temperature? For a mixture of ideal gases. Okay. What are the main features of an ideal gas? Mixture again possible. What are the features of an ideal gas? Right? So if you are doing chemistry, definitely you know. Unit 2 the go then the chemistry. 2 and then mula hari diyanne. 2, 3 gases mulane diyanne. Isn't it? Isn't it? 4. Are mulane? At the very beginning. First term. First term. Oh, tell me what are the features of ideal gases? Basic features ගොඩක් තියෙනවා. What are the features of ideal gases? Quickly. 15. What are the features of ideal gases? They are pointed particles, which means they have a mass, but yet they don't have a volume. Particle like a volume, right? Because it takes the entire volume of the room itself. Particle like volume, even though they have a mass, they have a mass, right? It does it. Collisions between molecules and molecules with holes are elastic, right? Elastic, no energy loss. What else? What about their speeds? Right? What about the speeds? Are they moving with same speed? Are all gas molecules moves with the same speed? What about the speed? Is it same or different? Same or different? What about online? Maybe chemistry case එකක් මම අහන්නේ. ICT කරනකොට දෙන අතර. Perfectly elastic. Travel මෙතින් හරියට මේ තියෙනවා. See මේ chat එකේත් උත්තර දෙනවා. May put it to the main chat either. Otherwise I don't see when I'm at the board. Right? Please put it to the main chat. Perfectly elastic. Correct. ඒක මම කියවනේ. Volume is negligible. මම කියවනේ. It has a travel in different speeds. They travel with different speeds. Random speeds. That is why we are dealing with a root mean square speed value, root mean speed, because they have a different speed. Root mean square speed is a root mean speed is an average speed. A mean speed, mean can average, root mean. Right? That's a mean speed. Mean is considered because they have different speeds. Hey, adinne Boltzmann curve and nekene speeds idi. Bell shape curve that's a speeds different. Majority is in this region, right? දන්නව නේද Boltzmann curve දන්නව? මෙන්න මෙහෙමයක් අඳිනවා. Speed variation එක. මේක මේ වගේ එකක් මම දන්නේ හරියට මේක කියලා. Boltzmann curve එකක් අඳිනවා. Bell shape curve එකක් වගේ එකක්. හරි. ඉතින් එහෙම තමයි speeds එන්නේ ඒකේ. Okay, different. What else? දැන් මේ features ආන්නේ. What else? Okay, let's see. හරි. තව තියෙනවා features. තව ගොඩක් තියෙනවා. They do a random motion නා ඒක. Motion එක මේ මෙතනත් එක්කම මාක් කරන්නේ. They do a random motion. Right? Linear එහෙම එකක් නෑ. They do random motion. Random motion in random speeds. Different speeds. Random motion in different speeds. Right. First one. This is about a mixture of ideal gases. Not a single gas. It's a mixture of ideal gases. First one. Different molecules have different speeds. Correct? No? Different molecules has different speeds. It is correct. Because higher the mass of a molecule, lower the speed. Higher the mass of a molecule, lower the speed. Kinetic theorem of gases. Right? Kinetic theorem of gases. Okay, molecules of each component of the gas mixture have the same average kinetic energy. Molecules of each component of the gas mixture have the same average kinetic energy. Correct. Correct. Because total energy of a gas is given as 3/2 kT. Right? මෙන්න මෙහෙම equation එකක් තියෙනවා that we are proving in gases 3/2 kT. Right? Chemistry වල තියෙනවා කියලා මම දන්නේ නැත්තරම. තියෙනවා. 3/2 kT total energy of an ideal gas. Right? K is where K is Boltzmann's constant. T is absolute temperature. Right? So therefore, this only depends on temperature. Right? Even though molecules are different, if temperature is same, as a whole, kinetic energy is same. Right? Mixture එකේ දෙකක් තියෙනවා නම් total kinetic energies of both are same. Molecule එකේ වෙනස් molecule එකට වෙන equation එකක් තියෙනවා. මේක අතරම U නෙමෙයි. This is E. Right? U කියන්නේ molecule එක. Molecule එක 3/2 nRT. මේක තමයි molecule එක. It changes with number of moles. Right? Moles කියන්නේ mass එකත් එක්ක change වෙනවා. It changes with the mass. Right? Molar mass එකත් එක්ක change වෙනවා. Higher the molar mass, lower the speed. Lower the kinetic energy. Right? Okay. So second one is correct. Second one is correct. Same kinetic energy. That is because of this Boltzmann's equation. The Boltzmann's equation, K is Boltzmann's constant. This is called the energy of an ideal gas. Total energy. Total energy of an ideal gas. 3. Lighter gas molecules have a lower average kinetic energy. වැරදිනේ දැන් මම කියවන. Lighter gas molecules have higher kinetic energies. Right? Lower the mass means lighter means lower. Lower the mass means higher the mobility. Higher mobility. So they are moving with higher speeds, higher kinetic energies. ඕන මේකට දාලා බලන්න පුළුවන් because n is simple m or capital M. හරි මේක. There's no chemistry behind this. මෙතන මේක දාන්න දන්නවනේ මේ number of moles can be expanded as total mass over molar mass. Right? So this is total mass over molar mass RT. Higher the molar mass, lower the kinetic energy. Right? Average kinetic energy of a gas depends only on temperature. Correct? Average kinetic energy depends only on temperature. Root mean square velocities of gas molecules of each component of gas mixture depend on molar mass of the gas. Correct? Root mean square speed එකට velocity equation එකක් තියෙනවා. Kinetic theorem of gases. මෙන්න මෙහෙම එකක් prove කරනවා දන්නවනේ. Gases, kinetic theorem of gases, kinetic theory. Right? So we'll be proving in thermal, right? Kinetic theory of gases. So answer is 3. 15, answer 3. For 15, answer 3. 16. A broad beam of parallel light is to be converted to a narrow beam of parallel light. This can be achieved with, okay, a broad beam is to be converted to a narrow beam. Basic behind this is this. Only lenses are given, no? Yeah. Only lenses are given. Right? මේක නම් මේ ඕලස් වල තියෙනවා. lenses තියෙනවා. නැද්ද? තිබ්බනේ. ඒක තමයි. නැද්ද අතරම? Mirrors and lenses නැද්ද? These lens. මේක දන්නවනේ. If parallel beam of light falls onto a convex lens, it will be converged at the focal point. It will be converged at the focal point. Okay, right? If a parallel beam of light is fallen onto a concave lens, right? Concave lens, it diverges as it is coming from a common point that is called the focal point. Right? මෙන්න මේ දෙක දන්නවනේ. හරි. මේකෙන් තමයි ඔක ආගිව් කරන්න දෙන්නේ. Two convex lenses. හරි. Two convex lenses නම් මෙහෙම කරන්න පුළුවන්. A parallel beam of light falls onto the convex lens, right? And we have, let's say, another convex lens. Two convex lenses. Here make up. This is called the principal axis. Principal axis, right? When we make up karno. What about now? See, this is decreased. Because this focal length is greater than this focal length. මෙහෙම කේස් එකක් දාපු ගමන් මේක කරන්න පුළුවන්. It is doable. Correct? මේක ඇඳලා බලන්න ඕනේ, right? දන්නේ නැත්නම් ඇඳලා බලන්න ඕනේ ඉතින්. You have to draw the light ray and check whether it's coming or not, right? මෙහෙම තමයි මේක කරන්නේ. And the same concept is used in telescopes. Right? මේ telescope එකේ තියෙන concept එක මේ තියෙන්නේ. Second one, two concave lenses. මේ જાතිය දෙකක් මම අඳින්නේ නැහැ එකෙන් කරන්න බෑ. right? මේකෙන් කරන්න බෑ. පුළුවන් එක විතරක් ඇදලා වෙනවා මේකෙන් කරන්න බෑ. මොකද මෙයා ඩයිවර්ජ් කරන්නේ. ඩයිවර්ජ් කාට පස්සේ ආයෙ ගන්න විදියක් නැහැ. ඩයිවර්ජ් කාට පස්සේ ආයෙ parallel beam එකක් ගන්න බෑ. right? If there is diverged, again we can't have a parallel beam. A convex lens and a concave lens. ඒක පුළුවන්. A convex and a concave. ඒක වැඩ කරන්නේ මෙහෙම. මේක convex එක දානවා. මෙයාට පුළුවන් නෙමෙයි. Now listen. There is something in optics as alternative property of light, which means if something works one way, it works the other way too. That is called alternative property of light, right? If something works one way, right, for sure it works for the opposite way, the vice versa. Vice versa එක අනිවාර්යයෙන් වැඩ කරනවා, right? From reflection, refraction, everything, anything and everything, that is valid. මොනවා මිරර් එකක් තියෙනවද? මිරර් එකක් ඔයගොල්ලෝගේ මිරර් එකක් වෙන්න ඕනේ නැහැ. මොනවා හරි රිෆ්ලෙක්ෂන් වෙන එකක් තියෙනවද? නැහැ. අපිලේ හිනා වෙනවා. මොකද හිනා මේකෙන් මේ මගේ ඉමේජස් පේනවද? නැහැ. කවුද රතු මේ අදීශර මාව පේනවද? පේනවනේ. right. මේ බා assume this as a mirror. Assume this as a mirror. Alternative property එක පෙන්නන්නේ. right? මේක example එකක්. there are plenty. mirror එකක් නැන්නේ. නෑ. selfie camera එකෙන් බෑ මොකද? ඒ නැත්තම් ඒක දායන්න mirror එකක් ඕනේ. ඒකේ reflect වෙන්නේ නැහැ. නෑ මොකද shining something නෑ මේට වඩා එකක්. okay. look at here something like this. So others you can try at home using a mirror. right? mirror එකක් lenses තියෙනවා ඒත් කරන්න පුළුවන්. ගෙදර lenses නැතුව ඇදිනේ. so try using a mirror, right? Normal mirror එකක් ගන්න. right? mirror එකේ now if this is directed this way, right? go this way. If this is directed this way, now I'm visible to you. පඩම පේනවද? දැන් පේනවා. that is because I can see you. හරි මගේ ray එක යන්නේ මෙහෙම. මට අදිශව පේනවා. because this ray from my eye to him goes like this. මේක තමයි reflection එක. ඒකේ comeback එකකුත් ඒකනේ. return එකකුත් තියෙනවා. return එකෙන් ඔයාලට මාව පේනවා. හොරෙන් බලන්න බෑ මිරර්ස් වලින් හොඳේ. හොරෙන් බලන්න බෑ මිරර්ස් වලින්. It is two way, it's always working two way. Right? ඒ කියන්නේ දැන් මට පේන්නේ නැත්තම් මම දන්නවා ඔයගලන්ට මාව පේන්නෙත් නැහැ කියලා හොඳේ. දැන් මෙහෙම තියද්දි මට අදිශ විතරයි පේන්නේ. වෙන කාටවත් මේකෙන් මාව පේන්නේ නැහැ. I'm sure. එහෙම තමයි. දැන් මෙහෙම තියද්දි කොහොම මේක ඔන්නවා. තව කවුද ඉන්නේ? ප්‍රෙස් වෙනව නෙමෙයි මොනවද දෙනවා? right හරි දැන් මට මිනසිව පේනවා. ඒ කියන්නේ ඔයාලට මගේ රිෆ්ලෙක්ෂන් එක අනිවාර්යෙන් පේනවා. that's the thing right ඔය පැත්තට හරවන්න මට හැරෙන්න ඕනකට that's the thing ඒ කියන්නේ always alternative property of light is there. Alternative property means if it works one way vice versa also works right ඕන තැනක ඕක valid. ඒතර මෙතනත් valid. So if a parallel beam falls, if it diverges, right? If a converging beam falls, it will be parallel. දෙපැත්තටම වැඩ. right? මේක මේ පැත්තට fall වුණොත් මේ පැත්තට එනවා. right? Either way it works. මේකම මේ පැත්තට අදින්න පුළුවන්. This is called alternative property of light. මෙහෙමත් වැඩ. right? මේක මෙහෙමත් වැඩ. Alternative property of light. right? So mirrors use කරලා හොරෙන් බලන්න එපා. අනිවාර්යෙන් බලන කෙනා බැලුවොත් පේනවා. ඊට ඔය සයිඩ් මිරර්ස් වල මේ දැකලා නැද්ද මේ? දැකලා නැද්ද කියන්නේ? who are driving? ඔයා drive කරනවා. මේ සයිඩ් මිරර් එකෙන් අපිට අනිත් එකව පේනවා කියන්නේ they also can see us. That's the thing. Right? Unless our car is having a darker tint or something like that. They can see us. අපිට පේන විදිහට මේගොල්ලන්ට පේනවා. That is reflection. අපිට විතරක් බලන්න බෑ. Right? If you can see someone's face from the side mirror, usually it happens with when we are traveling in as a queues of vehicles in the front vehicle, we can see who is driving if you are looking at its side mirror. ඒ කියන්නේ යාට අපිව පේනවා. මේක තමයි වෙන්නේ. Alternative property of light. Okay, එයාද මේක අදින්න මෙහෙමයි. Now for this converging lens and for the diverging lens මෙයාගෙන් මෙහෙම diverge වෙන beam එකක් මෙයාට දෙන්න පුළුවන්. Then it will be parallel again. Got it? මේකෙම reverse එක. Alternative light ray. So that is also working. A and C. Answer 4. For 16, answer 4. Right? Take them down because sooner we will be covering these parts. Take them down. So that is why I have included the questions. Right? Any questions? Ask if there's anything. All good? Right, what about it? All good? Take them down. Those are the ray diagrams. Second day and then that is not possible. That is not possible. Right? The basic two diagrams are these two. Right? This is called alternative property of light. Alternative property of light. Right? If it works one way, the opposite also works. Vice versa also works. Is it clear? What about online? What about online? Is it clear? If any questions, please do ask. All good? 17. 17. 17. There is a tank of water on a trolley moving freely with a velocity 20 ms minus 1. Tank contains 100 kilograms of water and the mass of empty tank and trolley is 50 kilograms. Right. Suddenly, a hole at the bottom surface of the tank causes water to leak at a rate of 2 kilograms per second. 2 kilograms per second. The velocity of the trolley after 25 seconds is okay. Then we have to have the final mass of trolley and the system, right? So let's see what's the leak mass is. See, leak mass, right? Rate is 2 kilograms per second, and after 21 seconds, no? Then 2 times 25, 50 kilograms of water is already leaked now, right? Now we have two scenarios, right? Initially, I'm not drawing the trolley whole thing. Initially, total mass is 150 grams, no? Kilograms, no? 150 kilograms. It was moving with the speed 20, right? Now finally 20, no? 20. Now finally 50 is lost, which means this is 100 grams, 100 kilograms. We need the velocity, let's say u, right? So apply conservation of linear momentum, right? Using conservation of linear momentum, right? M1 V1 equals M2 V2, right? Only one mass is here, no? Then this is what I'm going to apply. M1 V1 equals M2 V2. Mass is 150 into 20, 100 U. 50 times 2, 50 times 3, 2 times 10, U is 30. Answer 2. That's a good question. Linear momentum, right? Now, what is the basic requirement we should have to apply linear momentum? Right? In the law itself, it's there. What's the basic requirement or the fundamental requirement to be satisfied to apply linear momentum? Couldn't hear. Unbalance? I guess you are saying the correct one. I couldn't hear it. Unbalance? External force? Oh, nothing now, right? External unbalanced force should be 0, right? Because linear momentum is defined as, the law is stated as when there is no external unbalanced force acting on a system, right? Then only total linear momentum of the system is conserved, right? Even though it is leaking from here, no unbalanced forces, no external forces, right? So that's why we can apply linear momentum. Take it down. Take it down. Any questions? Any questions? 18. The relationship between speed, frequency, and wavelength of a wave is given by V equals F lambda. Right? Given by V equals F lambda. Right? A very popular equation. V equals F lambda. Consider the following statements about this relation. A. It can be applied to any wave at any instant. What about it? Any wave at any instant. True or false? Any wave in the sense for any type of a wave at any instance. True or false? V equals F lambda. That is actually called the general equation of a wave. General equation of a wave. It is applicable for any wave. That's the general equation of a wave. V equals F lambda. Yes. That is the general equation of a wave. Right? Frequency of the wave depends on speed of wave. Frequency of wave depends on the speed of wave. In one of the last papers also I explained. frequency is the only unchanged parameter of a wave, even though it undergoes refraction or any wave phenomena. Frequency is the only one unchanged parameter of a wave, frequency, which means frequency is independent of the speed. Right? Frequency is independent of the speed. Make an example like make. So you know this N1 V1 equals N2 V2. N1 V1 equals N2 V2. Right? V equals F lambda. Then this is F lambda 1. And this is F lambda 2. See? Now in this equation also there is no frequency included. In this equation also there is no frequency included. Yet velocities are different. Yet velocities are different. Yet velocities are different. Right? Write down in red again. I have written this before. I have written this before in one paper. Right? Write down this in red. Only parameter which remains unchanged of a wave. Only parameter. Only parameter. Only parameter which remains unchanged. Only parameter which remains unchanged of a wave is frequency. Is frequency. C. So this is wrong. Huh? B is wrong. C. Since the speed of light is constant, this cannot be applied to light waves. Since the speed of light is constant, this cannot be applied to light waves. What do you say? Can be applied. Can be applied. Then this is applicable for any wave. Light waves and the other main point about this statement is it says since the speed of light is constant, the speed of light is constant in a given medium only. If medium changes, it changes. Right? Speed of light in gas mediums is 3 times 10 to the power 8. So that is what you mostly know. Right? The speed of light in gas. The speed of light in liquid is in liquid means in water is 2 times 10 to the power 8. Decreases. When methane decreases, higher the refractive index, lower the velocity. Right? So therefore that is different. That is constant for a given medium. If medium changes, speed changes. C is wrong. C is also wrong. Only A. Only A. Answer 1. For 18. Answer 1. 19. 19. A tank of volume 0.75 cubic meters is 20 meters above the ground level. Okay, this is 20 meters above the ground level. Right? Tank of volume 0.75 cubic meters. A pump must do 150 kilojoules of work to bring this amount of water from the well to ground level. The pump takes 5 minutes to fill this tank. A pump must do 150 kilojoules of work to bring this amount of water from well to ground level. Alright. So කතාවක් මෙතන තියෙනවා. well එකකුත් තියෙනවා. Right? well එකකුත් තියෙනවා. Right? well දන්නවනේ. හරි. මෙහෙම well එකකුත් තියෙනවා. මෙතන ඉඳන් water එක ගේන්න මෙතනට 150 joules kilojoules. Right? ඊට මෙතන ඉඳන් මෙතනට අපි තාම දන්නේ නැහැ. The pump takes 5 minutes to fill this tank. If the density of water is 1000, the power of pump is okay. Right. What is power? What is power? Huh? Power. What is power? as an equation. Force into velocity, it is also correct. What is the general equation of power? E over, yeah, power is energy over time or work over time, right? So amount of work done per second is called power. Work over time, energy over time, right? And work to be done because power is work over time. Power is work over time, right? So let's find out total work done from here to fill this tank, right? Okay. Total work. See, total work should be starting from here. Now the pump is used. මෙහෙම pump එකක් තියෙන මොකක් හරි. අපි දන්නේ මොකක් හරි මෙහෙම pump එකක් තියෙනවා. This is a pump. Right? So initially, water should be taken from well to the ground level now. And it says it needs a work of 150 kilojoules. ඒ part එකේ ඒතකොට given, it's given 150 kilojoules. මෙතන ඉඳන් මෙතන lift කරන්නත් ඕනේ. Because tank is located 20 meters above ground. Then using the pump, it should be pumped to 20 meters vertically upwards. Should be pumped to 20 meters vertically upwards, right? Then let's do this way. Hari, මෙතන work එකමනේ මේ දීලා තියෙන්නේ. See? Now this is the work. This is the work to be done from well to ground, right? This is a work to be done from well to ground. Well to ground, right? Now whole amount of water is on ground, right? And that amount of water should be taken from ground to 20 meters, ground up to 20 meters, right? Then work can be written as mgh, work equals difference of energy, or else work can be written as force into displacement, right? If one water molecule is, let's say, mg into h, right? Total m that is mgh. This can be written as mgh, right? And see, work can be written as mgh, but we know m is not given. M is not given. Instead, volume and density is given. What is the difference? What is the relation between mass and volume? Mass, volume, and density. Mass, volume, and density. Mass equals V rho, volume times density, right? Then this is V rho GH, no? Right? So I'm going to plug this value here at once. V, total volume should be 0.75. 0.75. Rho 10 to the power 3. G is 10, H is 20. And this whole process takes 5 minutes. Right? 5 minutes should be in standard units 5 into 60 seconds. Right? Simplify and see. Simplify and see. I can see 10 to the power 3 is common here. Actually, 10 to the power 4 is common. I'm going to take it out. 10 to the power 4 is common. Right? Then here 15 remains plus 10 to the power 4 is taken out. This 10 to the power 3 and this is taken out. 0.75 into 2 into 20 means 15. Again 15, no? 15 over 5 times 60. 10 to the power 4 times 30. 5 times 60. 30 times 2. Right? This is again 10. It makes 10. 10 to the power 4 over 10. This is 10 to the power 3. Right? 10 to the power 3 means 1 kilowatt. 1 kilowatt. Answer 3. This is also a good question. Right? And not a whole new idea. Right? My idea ke use kala dena untaran questions in past papers, even in past papers. Right? Grab this idea. Grab this idea. Now, water is taken from well to this point. Right? May part 150 plus pump does another work as mgh from ground to here. Right? This is exactly what is done when your water tank is filled with a water motor. Right? Usually, water motors, right? Unless you are taking it from the water board. Got it? Now, if you have a water motor, pump එක දාලා තියෙන්නේ මේකට දාන්න මොකද්ද ඒකට කියන්නේ මේ මොකද term එක මොකක්ද මේකට දාන්නේ මේක absorb වෙන එක foot valve. foot valve දන්නේ නැද්ද? මෝටර් එකේ අගින්ම තියෙන්නේ. ගලවලා බලන්න කියලා. foot valve කියලා ඇත්ත. මේ වැල්ලක් මේක අස්සේ තියෙනවා. right? මේ ලින්ද දැකලා නැත්නම් ලින්දර ගලවලා බලන්න මේ බයික් ඇතුලේ බටයක් තියෙනවා. ඒක දිගින් යන්නේ. right? So if your tank is located, let's say 20 meters above, right? This whole work is done by motor, by rotating the motor. Motor rotate කරලා අතන තව පොඩි dynamics, fluid dynamics part එකක් යනවා. The work done කරන්නේ මෙහෙම. Right? To provide energy to rotate motor, we are using electricity. Right? The motor එකේ electricity use කරන්න නැතුව හුලගෙන් කරකවන්න පුළුවන් නම් ඒත් ඔක් කරන්න පුළුවන්. Somehow that work to be done, work should be done. Right? එහෙමයි වෙන්නේ. More higher the height you are taking it, higher the stored potential energy. Right? When higher stored potential energy is there, which means when it is coming back also, it has comparatively higher kinetic energies. That is why motor is having comparatively higher velocities. We say more pressure කියලා කියන්නේ නිකන් කතාවට. More pressure when the tank is more higher. Right? The main store energy එක අනිත් පැත්තට එන්නේ. That's a conservation of energy. Right? අර water pressure මදි කියලා කියන්නේ. water pressure මදි නම් tank එක උඩට දාන්න ඕන. දැම්මම ඉතින් මේ potential energy එක වැඩි වෙනවා. එතකොට අරගේ speed එකත් වැඩි වෙනවා. That's a physics behind it. Right? ඒක බට මේවා කරලා කරන්න පුළුවන් because A1 equals A2 V2. එක එක තියෙනවා. water pressure එක තමයි main එක. දන්නවනේ tank එකකින් එන්නේ 2 inch එකක්. for normal tap lines that is a half inch. භාගේ බටේ කියන්නේ. අපෝ දන්නේ නැද්ද? Because A1 equals A2 V2. Fluid dynamics. අපි dynamics section එක කතා කරා. සම්මයා. Right? ඉතින් එහෙමයි වැඩ කරන්නේ. Everything that you see here means in the world can be explained using physics. Right? That is how physics is defined. What is the definition of physics? Since you are learning physics, what is the definition of physics? Why we are learning physics? Online. What is the definition of physics? As you know. Huh? Any thoughts? Definitions? Okay, any thoughts? What type of a subject is this? What is your thought about physics? So time goes stuck again. So why are you learning physics? Just for the sake of getting an A grade, is it? Right? A got I physics on that. Is that the thing? Huh? Just for the sake of going through A levels. You are learning physics. Huh? Oh, ඇත්තටම මේක තමයි වෙන්නේ නේ. ඇත්තටම මේක තමයි වෙන්නේ. දැන් ඇත්ත. That's the bitter truth. That's the bitter truth. ඒ කියන්නේ physics ඉගෙන ගන්න ආස වෙලා නෙමෙයි ඔයගොල්ලෝ physics ඉගෙන ගන්න ආවේ. Yeah, I'm serious. That's the truth. But you should know what is physics. Okay, physics කියලා කියන්නේ මෙහෙම එකක්. Physics is a science of studying physical behaviors of objects and basically objects and physical name natural phenomena. Now physics define කරන්නේ. Physics is a study of physical behaviors of objects and natural phenomena. ඔක තමයි physics කියන්නේ. අපි මේ learn කරන ඕන එකක් මම ඔය කියපු වචන දෙක ඇතුළේ දාන්න පුළුවන්. Right? Physical behaviors and natural phenomena. Right? What is this? Physical behaviors. Physical behaviors. What are the natural phenomena? Refraction of waves. That's a natural phenomenon. Right? A motion of a car. That's a physical behavior. Physical movement. That's a physical behavior. Right? Electromagnetic rays. Light force. Natural phenomenon. Right? ඔය කියපු දෙක ඇතුළත මේ physics වල ඕන එකක් දාන්න පුළුවන්. Right? ඒක තමයි physics කියන්නේ. Right? Say you are learning matter and radiation, unit 11. Natural phenomena. ඔක්කොම වගේ natural phenomena තියෙනවා. Nuclear reactions, nuclear binding energies, all of them are natural phenomena. Right? එහෙම තමයි හැදෙන්නේ. Right? Sunlight comes from sun to ground. It's a natural phenomenon. Like a waves shall be explained karne. It's a natural phenomenon. Right? Gravitational fields. Gravitational fields kiyana okkoma. The revolution, rotation of Earth, and everything. Daytime, you are getting daytime and nighttime, everything. They are physical behaviors. They can natural phenomena part type. They are physical behaviors. Physical behavior is Earth is revolving. That's a physical behavior. Right? Okay, that's enough. Google kala bala. Right? Then that's Google kala. Okay. Which of the following is correct regarding the centripetal force and centrifugal force? Ame kalla and method right. Yeah, either. Câu mẹ ta. This will be available on YouTube. Balanna. Right. Safe. Okay, go safe. Arute gahanna balagina nathinde mage. Right. 20. Which of the following is correct regarding the centripetal force and centrifugal force? Okay. One name A. See? Centrifugal force is the equal and opposite reaction of centripetal force. What do you say? Okay. What about the directions? Centripetal force. What is the direction of centripetal force in circular motion? What is the direction? Towards center. Centrifugal force away from center. Right? Now it says they are equal and opposite reactions of each other. True or false? False. True. Huh? False. F. It is false. Api circular motion questions kara. See, one example. Simple example. This is a car which takes a horizontal bend. Right? This is a car which travels in a horizontal bend of radius r, let's say. Look at here if you don't know this. Right? Now, from the circular motion itself, centrifugal force is generated. Right? Centrifugal force is not something generated externally. Centrifugal force is the force generated by the circular motion itself. Right? Centrifugal means that is away from center. To counterbalance centrifugal force, centripetal force comes. Right? Now here, say friction acts. Right? So friction is centripetal force. If I write centrifugal force as an equation of centrifugal force is mv squared over r. Right? This is a frictional force. This is a centrifugal force, mv squared over r. There is no any relationship as action and reaction. Make a friction. Is this a friction? No. Not at all. Right? Always to counterbalance centrifugal force, centripetal force comes. Right? Say you are doing something with a tension of the string, something like this. Last week discussed conical pendulum. Same thing. Conical pendulum. Now, from this T cos theta acts as centripetal force. To counterbalance this centrifugal force of mv squared over r. Is this a tension? No. That is force. Right? They are not equal and opposite reactions. They are not mutual reactions. Right? Wrong. A is wrong. That is kind of straightforward. A is wrong. But centrifugal force and centrifugal force and centripetal force should be equal in magnitude and opposite in direction to undergo a complete circular motion, to undergo a proper circular motion. But that doesn't mean they are equal and opposite reactions. Reactions again, it should adhere Newton's third law. Right? If it says mutual reactions, it's a big statement because it should adhere Newton's third law. Is it due to contact? No. Right? But centrifugal force and centripetal should be equal and opposite. That is true. That is for the proper circular motion. It's not a reaction and action. Right? Okay, that is wrong. B is wrong. A is wrong. B. B. An object is rotating. An object in a rotating frame appeared to have no centripetal force as observed by an observer in the same rotating frame. Okay, it's like this. Wait here. We have discussed in theories about the force frames and the behavior of centripetal and centrifugal forces. Okay, listen. Now this is a good part in circular motion, a sensitive theory part in circular motion, and more frequently questions are also coming from this part, right? Okay, this is an example. See, say this is a bus. This is a bus which travels in a horizontal bend. This is a bus which travels in a horizontal bend, right? And there is a pendulum. There is a pendulum suspended on the bus, right? Now, when this bus takes the bend, to which direction this pendulum goes? To which direction it goes? Away from center or towards center? Away from center because of centrifugal force. Away from center because of centrifugal force, right? Centrifugal force. Force. Because of centrifugal force, it goes away from center, right? Now let's say there is a person A inside the bus, and there is another person. There is another person B outside the bus. There is another person B outside the bus, right? Okay, something like this. Something like this. With respect to A, with respect to the person who is undergoing circular motion. A is undergoing circular motion, no? Right? A is traveling in circular motion. So with respect to A, right? Now think of a situation where you are traveling on a bus. In which direction? Explain. Yeah, I explain. Right? In which direction you feel this force? Away from center or towards center? If you are on the bus, away from center, which means what we feel is centrifugal force. What we feel is centrifugal force when we are inside the bus, right? Which means this person feels centrifugal. This person feels centrifugal force, right? He don't even know, he or she, I don't know. He or she don't even know, doesn't even know whether there is a centripetal force. Whether there's friction on our body. But what we feel is we are going to go away from center, tend away from center when it takes a bend, right? That is because of centrifugal force, right? Okay, now a person who is outside the bus, looking at the motion of the bus is taking the bend. Now, whatever the ones who are standing, they also bends like this, and if they are seated, they are also having the same force, and they tend to go away from center. What about this person? In which direction does he try to bend? B. If he is looking at the bus, outside the bus. Now bus is taking the bend. Now the ones inside the bus is feeling the centrifugal force, and now they are moving away from center. They are moving away from center. What about this one? Is he moving away from center? Towards center. Oh, he's at rest. This one is at rest. Circular motion. This person is at rest, right? Only the ones who undergo circular motion will feel centrifugal force, right? Then mum bus එක දිහා බලන් හිටියා කියලා. අපි එළියෙන් බලන් ඉන්නවා. අපිට මෙහෙම වෙනවද නෑනේ? We don't have a centrifugal force. Right? ඒක ඉතින් අපිට නෑ. Centrifugal force is only when if you are in a circular motion, right? ඒතර මෙයාට centrifugal force එක තියෙනවා. But what this person observes is this bus takes a bend. Takes a bend means it takes the bend this way now. Listen, this is the most important part. Now it takes the bend this way, right? Now naturally, when we observe a motion if it travels downwards, the force is, direction of force is what? If this travels downwards, natural direction of force is downwards. F equals ma. If there's a force, there will be an acceleration, velocity, and all that. Right? Decelerations කියන එක අයින් කරලා දාන්නකො. Decelerations අමතක කරා. Forget about decelerations. Naturally, motion is towards the direction of force, no? Right? Now this motion is away from center towards center. දැන් මෙයාට පේන්නේ as it is seen by B. Is it going towards center or away from center? As it is seen by B, towards center. Because this one says that bus is taking the bend. Taking the bend means the bus is bending towards the center. So therefore, this one sees means this one understands, this one understands about centripetal force. According to his knowledge, what he understands is centripetal force, because it takes a bend, right? But the ones who are actually in the circular motion understands the centrifugal force, not the centripetal force, right? අපි බෙන්ට් එක යද්දී අපිට බෙන්ට් එක කොයි පැත්තටද කියලාවත් සමහරලාට එහෙම පේන්නේ නැහැ, right? අපිට feel වෙන්නේ මොකද? What we feel is centrifugal force. This is the difference. මෙන්න මේ difference එක අපි, this is a very sensitive part in circular motion. So therefore, centrifugal force can only be felt by the objects which undergo circular motion, right? And centripetal force can be felt by the outsiders. Felt in the sense they can understand it, right? Now, scenarios. If I mark forces acting on this with respect to B, look at this. If I mark forces acting on this object with respect to B, right? What B knows is this T and mg only. What B knows is this T and mg only. T and mg only, right? Centripetal force is one component of this, no? I mark කරන්නේ. මේක තමයි මෙයා දකින්නේ. And if I mark these forces with respect to A, if I mark forces acting on this with respect to B, what he knows is all three with this. There is a difference. Because A is actually in circular motion, so he knows there's a centrifugal force, right? So this is called force frames in circular motion. This is a force frame of B, this is a force frame of A. And this is also called reference frames. This is a reference frame of B, this is a reference frame of A. Right? Take it down if you don't know. This is a very important and a crucial part in circular motion. Right? It's a crucial part in circular motion. We have discussed this in theories. We have discussed this in theories. You should be able to recall. See, natural phenomena and physical behavior, same තමයි. Yeah, it's applicable for any point. ඒකේ definition එක. That's the definition of subject. ඇයි දැන්? අපිට කියන්න ඕන නෑ. ඈ? මම මාකරි බස් එකේ ඉස්සෙල්ලා මතක වුණා. මම හිතා බස් එකේ වෙඩ් එකක් ගන්නකොට මම කරි සීන් එකක් මතක වුණා කියලා. When buses are taking bends, listen, when buses are taking bends, if there are ones who are tending opposite to the motion of the others, like now the natural motion, when a bus is taking a bend, is away from center, right? So if there are someone who have applied a higher effort, and if someone tries to move the other way, right? Move the other way, that is something they do intentionally. අපි එහෙම try කරනවා නේ, especially if we are standing, right? අපි මෙහෙම යද්දී සමහරවල් අපි මේ ඒක යන්න නැතුව ඉන්න try කරනවානේ. ඒ අපි counter force එකක් දීලා. natural movement එක මම මේ කියන්නේ. natural movement is moving away from center. එහෙම යන හින්දානේ අපි මේ අර කාගෙන කොහොම හරි effort එකක් දාලා මේ පැත්තට ඉන්න හදන්නේ. That is the counteraction for the centrifugal force, right? මම ඉතින් කිව්වා centrifugal force එක ඇක්ට් කරන්නේ කොහෙද කියලා. මම මේ ටික එක්ස්ප්ලেইন කරා ටිකක්. centrifugal force acting at yeah කිව්වේ නැද්ද? කිව්වනේ. yeah ah centrifugal force acts at මම කිව්වද නැද්ද? online? What about online students? What did I say about centrifugal force and acting point of centrifugal force in one of the last paper discussions? In theory class I have explained already. කිව්වද? නැද්ද? කිව්වා? What's the point? What's the point? Centrifugal force acts. Point එක කිව්වේ නැද්ද? කිව්වා? That is center of gravity. Acting point of centrifugal force is center of gravity. Center of gravity of object. Our center of gravity is at hip. මං hip එක ගැන කිව්වා. කිව්වා. Our center of gravity is at hip. So that is why we bend from the hip if you are traveling on a bus. Right? So that's the thing. Okay. මේක තමයි මේකේ theory එක. Mention this point in red. Mention this in red. Centrifugal force can only be felt. Write down. Centrifugal force can only be felt. Centrifugal force can only be felt. Centrifugal force can only be felt by objects which undergo circular motion. Centrifugal force can only be felt by objects which undergo circular motion. Right? බර මග තියාගන්න. Centrifugal force එක මේගොල්ලෝ දන්නේ නැහැ. Right? Now when we take a bend in the bus, even though we are struggling when the bend is taken, the bus speed and we have to struggle because moving of the body away from center is actually kind of a disturbance if you are standing on the bus or seating. Seating උනත් එච්චර තමයි. අනිත් පැත්ත එකක් ගිහිල්ලා ඇලෙනවනේ අර මේ වෙද්දි. තල්ලු වෙනවනේ. එහෙම තමයි. නැති කරන්න බෑ. ඉතින් that's a centrifugal force. Right? මේකට අල්ලගෙන ඉන්න ඕනේ ඉතින්. ඒක හරි. ඒක disturbance එකක්නේ. Right? සමහර නිදාගෙන ඉමිටියොත් එහෙම තවත් කරදරයි. That is a disturbance. Right? So all of the ones inside the bus, passengers inside the bus are struggling when this acts. But the ones who are outside the bus වලට ඉන්න එකේ අපිව දැකලා කොහොම වෙන්නේ නැහැ. ඒක තමයි ඒකේ තියෙන මේක. එයා දන්නේ නැහැ ඉතින්. එයාට ඒක වැඩක් නැහැ. වැඩක් නැහැ කියන්නේ. Outsiders cannot feel centrifugal force. Centripetal එක දන්නේ because of this direction of motion. එහෙම sense එකක් තියෙනවනේ. අන්නේ sense එකෙන් තමයි centripetal force එක කියන එක දන්නේ. හරි? එතකොට බස් එකේ ඔක්කොම කට්ටිය away from center යද්දී towards center යන අය ඉන්නවනම් ඒ අර වෙන විදිය මිනිස්සු එහෙම ඉන්නවනේ බස් වල. එහෙම කට්ටිය ඉන්නවා. ඉතින් කියන්නේ එහෙම බස් වල යනවනේ. ඉතින් අර ඉන්නවනේ එක එක ඔය මොකද උන්නේ කියන්නේ අර abuse මොනවාද අර එක එක මේවා ගන්න මිනිස්සු ඉන්නේ. එහෙම ඉන්න අතර හොඳ ඔය බෙන්ස් ගන්නකොට බලන්න. මේ I'm serious. ඔය බස් crowd වුණාට පස්සේ I'm serious මේ ඉතින් ශ්‍රී ලංකන් context එකේ ඉතින් තියෙන දේවල් ඉතින් ඒවා කතා කරන්න බය වෙන්න ඕනේ නැහැ. ඒක serious case එකක්. ඒක issue එකක්. right? මොකද්ද ඒකට කියන්නේ? harassments. මට දැන් වචන මතක් නෑ. transport වලදී තියෙන harassments තියෙනවා. right? එහෙම කට්ටිය ඉන්නවා මේ abuse නෙමෙයි අතරම harassments. right? right? harassments ඉන්නේ. I know. මේ ඉතින් එහෙම කට්ටිය ඉන්නවා. මේ ඉතින් පරස්සමෙන් එහෙම තමයි ඉතින් ශ්‍රී ලංකන් context එකේ ඒ case එක තියෙනවා because in peak hours all of our buses are crowded. right? මේ seating capacity එක නෙමෙයිනේ බස් එක යන්නේ. train එක යන්නේ seating capacity එක නෙමෙයිනේ. right? So it should be developed. right? It will be developed. But it takes some time. right? So still we are developing but it will be developed. It should be. right? මේ ඔය Indian leyland එක නෙමෙයි මේ transportation කරන්න මේ use කරන්න ඕනේ බස් එක. right? මේ luxury buses තියෙන්න ඕනේ. එහෙම තමයි ඉතින්. ඕක නෙමෙයි බස් එක. ඕක බස් එකකුත් නෙමෙයි ඕක ලොරියක් නේ ඇත්තටම. බස් chassis එක ඒ කියන්නේ බොඩි එකන්නේ ගහලා තියෙන්නේ. ඇත්තටම ඕක ලොරිය. දන්නවනේ. ඉතින් ඒ නිසා මේ that is not the ideal one or the proper one for the passenger transport. That is not a bus. හරි ඒවා අපි බලමු. ඉතින් ඒවා හරියන්න ඕනේ. දැන් developed countries වල ඉතින් ඔහොම මේ rush එකක් කියන්නේ there's no overcrowded buses. Right? ඒකට ඉතින් regulations තියෙනවා. But in our case, number of buses is less than number of passengers at peak hours. ඒ හින්දා we have to. Right? කවුරු දාලා යන්න බෑනේ. So we have to. එහෙම තමයි හැටි. Okay. So be safe when you are traveling in the compact crowded buses, especially in peak hours and especially if you are standing. Right? මේ boys girls කියලා නෑ හොඳේ. I mean it's common. I'm serious. Serious කියන්නේ. ඒක මාර කේස් එකක්. ඒක හරි අවුල්. හරි boys girls කියලා නෑ. බොරු නෙමෙයි හොඳේ. hina වුණාට. නෑ hina වෙයි බලන්නකො. එහෙම එකක් සෙට් වුණොත් බලන්නකො. කෑ ගහපන්. වෙන එක ඒක ඇත්තම කියන්නේ. මේ ඕන තරම් මේ boys cases තියෙන හොඳේ hina නෙමෙයි. මේ anonymous articles ඔය කට්ටියගේ මේ එක සර්වේස් වලට ගත්තා තියෙනවා. right? මම හිතලා නෙමෙයි මම මේ කියන්නේ. සර්වේස් කරනවා වල. right? researchers වලට. To conduct researchers, usually social researchers, right? ඔය campus වල ගන්නවා. ඒ research social research යන research check කරන්න data ගන්නවා. As surveys from general public, right? දැන් ඔය වගේ case එකක් නම් they will be anonymous data. Right? Since they are anonymous, their accuracy is higher. Right? නම් එක ගත්තා නම් අපි කියන්නේ ඒ කියන්නේ සමහරවිට we have some reluctant to say that we have got harassed no. අර එහෙම එකක් තියෙනවනේ. So therefore anonymous data are collected. ඒ data වල ඇත්තම case එක වැඩිපුර ඉන්නේ කොල්ලෝ. ඇත්තම ඒක මාර case එකක්. හරි මම දන්නේ. Okay. මම මේක ඕගොල්ලන්ට කියන්නේ this is because you are traveling in buses in maybe day to day basis when you are going to classes and coming back and all that, right? So be safe. Right? මේ කොරනද කොළඹද කැන්ඩිද මොකද්ද කියලා නෑ. This is a general problem, general issue we have in Sri Lanka. Right? ඒක තාම තියෙනවා. Now that is kind of less compared to earlier days. කියන්නේ මේ අපේ කියන්නේ මේ දැන් ඉන්න young generation එකේ ඔය කේස් එක නෑ හොඳේ. serious. ඔය ඔක්කොම researchers මම මේ කියන්නේ. ඒක ඇත්තටමත් ඕගලන්ට experience ගන්න පුළුවන්. ඕක අර mid age එකත් තනපුවා එක තමයි ඔය කේස් එක තියෙන්නේ. ඇත්තම කතාවක් මේ කියන්නේ හොඳේ. for your own betterment. right? ඒ කියන්නේ around නෙමෙයි more than 45 50 අර වයසුන් ඉන්නේ. ඒගොල්ලන්ගේ තමයි ඔය cases වැඩි. ඇත්තටම. මේ young generation එකේ නෑ ඇත්තටම. ඇත්තටම. ඒකට එක cases තියෙනවා අපිට වැඩක් නෑ. මේ young generation එකේ නෑ. So therefore it is in a declining trend. But yet it's there. අර generation එක නැති වුණාට පස්සේ ගොඩක් නැති වෙනවා. ඉතින් අපිට මරලා දාන්න බෑනේ උන්. නැති වෙන ගාන naturally නැති වෙන ගා ඉන්න ඕනේ. ඒ generation එක නැති වුණාට පස්සේ ගොඩක් දුරට අඩු වෙනවා. I'm not saying it's zero in young generation, but it is very minimum compared to the older generation, the mid-age and older generation. Right? එහෙම තමයි ඇති. يعني ඉස්සර බසස් වල ගිය කේසස් එක දැන් සෑහෙන අඩුයි. දැන් ඔය බසස් වල CCTV එහෙම දාලා දිනවනේ සමහර අය. දාලා දිනවනේ. මේ දැන් එක එක regulations එකත් අඩුයි. මේ ඉස්සරහම නෙමෙයි ඉස්සර මාරම අවුල්. But yet it is in a declining trend. Not zero. Right? So be safe. Especially when you are traveling in crowded buses. Right? Especially. ඒක වෙනවද? මේ කොල්ලෝ කියලා නෑ. I'm serious. Right? Right? So if someone tries to touch you, you have to take an action. Don't just wait without saying any word. Right? ඕන video එක හරි on කරගන්න. That's enough. If you can't say anything, you are using mobile phones no? Right? Video on කරගන්න. That's it. Video on කරලා අරුගේ මොන්ට අරන් එච්චරයි. එහෙම තමයි. ඉතින් ඒ ගැට් එක තියෙන්න ඕන නැත්තම් බෑ. නිකන් බලා ඉන්න එපා. Right? For both boys and girls. right? කෑ ගහන්න පුළුවන් නම් කෑ ගහන්න. ඉතින් ගෑල්ලව නම් කෑ ගහනවනේ. මේ එහෙම කියන්න ඕනේ. ඇත්තටම එහෙම කරන්න ඕනේ. එහෙම කරේ නැත්තම් තමයි එතන කේස් එක. ඒතර ඌ එතනින් නතර වෙන්නෙත් නෑනේ. He'll be doing the same on another bus on another day. Right? මොකද ඒකට punishments තියෙනවා. ඒවා දෙන්න ඕනේ. දැන් simply දැන් මේ කියන්නේ in this modern era what we can simply do is getting a video. Full evidence. කෙලින්ම කොමඩ එක තියෙනවා. ආයේ මොකුත් කියන්න බෑනේ. Right? ඒක තමයි දැන් best මේක. Okay. See, both centripetal force and centrifugal force are required for existence of circular motion. Definitely yes. And the requirement is this. Requirement is this. These are requirement for proper circular motion. For proper circular motion, centripetal force equals centrifugal force. These are requirement. Right? So what happens if centripetal force is greater than centrifugal force? Here. What happens if centripetal force is greater than centrifugal force? This object travels away from center. It leaves the circle away from center. Right? That is what happens higher speeds, at higher speeds, especially in supercar racing and all that. Right? The accident වෙන්නේ away from center. කවදාවත් මේ බෙන්ඩ් එක ගන්නකොට මෙහෙ ඇවිල්ලා accident වෙන්නේ නැහැ. The audience here will be injured. That is because of the higher centrifugal force, because when velocity increases, centrifugal force increases as a square. If velocity is increased by 10, the impact of centrifugal force is by 100. ඒක තමයි impact එක. ඒක මේ මොකද කියන්නේ exponential increase එක. That is an exponential increase. Right? If centripetal force is increased by, if speed is increased by 20 times, centrifugal force increased by 400 times. That's the impact. Right? And that's why especially in race බලනවා නම් මේක දන්නවා. Right? Higher the speed, right? If the speed is more than the what we call the safe speed, right? Always that car or bike or whatever it is will go away from center like this. It will go away from center. Right? So therefore, if you are watching a race or something like that, in the audience, don't stay this side. Right? මේ පැත්තේ seats තියෙනවා. ලංකාවේ තියෙනවා හැමතැනම තියෙනවා. මේ පැත්තේ seats ගහනවා. ඒක අයින් කරන්න ඕනේ. මේ අර නෝරෙලිය වෙච්ච එකේ මැරුණා මිනිස්සු. මතකද? 3 years old වගේ කලින් මේ crash එකක් වුණා. දන්නද? මේ නෝරෙලිය crash එකක් වුණා මේ like 2 years 3 years back. මේ audience එකේ දෙන්නෙත් කොහෙද මැරුණා? That's a tragedy. Right? එහෙම වෙන්න හොඳ නැහැ. ඉතින් මේ පැත්තේ audience එක ගහන්න හොඳ නැහැ. audience එක මෙහෙ තමයි ඉන්න ඕනේ. crowd එක. Right? මේ ගහනවා නම් අර මේක පිටරටවල ගහනවා. In other countries there's a safe zone covered with sand or something. අන්නේ zone එකෙන් පස්සේ තමයි අපේ එහෙම නෙමෙයිනේ. මේ sand එකෙන් පස්සේ තමයි seats ගහන්නේ. අපේ එහෙම නෙමෙයිනේ race එක මෙහෙම යද්දි මෙහෙම බලන්න race එක ගිහිල්ලා. එහෙමනේ යන්නේ. ඉවරයි ඉතින් මොකක් කරනවා? ඔය මේ නෝරෙලිය මොකද්ද සුපර් ක්‍රොස් එක ගියේ මිනිස්සු දෙන්නෙක් කරනවා මොනවද විදියට එහෙම යනවා මේ ඕක අර ස්ලෝ ඩවුන් කරන්න මේකක් තියෙනවා පොඩි සේෆ් සෝන් එකක් ගහනවා සමහර මේ ට්‍රැක් වල පිටරට මෙහෙම සේෆ් සෝන් එකක් ගහනවා it's filled with sand ඒතර sand වලට ආපු ගමන් sand වල velocity එක absorb වෙලා ටක් ගාලා මේක ස්ලෝ වෙනවා මේක සමහර highways වලත් ගහනවා මේ highways කියන්නේ expressways වල braking case වල එහෙම ආවම හරි දැන් මේ මතක් කරනවා ඉතින් මම කියන්නේ මේක මේ safe zone එක using sand පොඩි අර මේ මොනවද අර silk sand වගේ තියෙන්නේ සිලිකා වගේ අර silk sand අන්න ඒවෙන් ගහන්න. ඒතර අපි sand අස්සර wheels ගියකපු ගමන් it immediately decelerates. right මේ highways වල මේකට කියන්නේ මට නම් මතක නෑ. highway එකේ lane එක මෙහෙම තියෙනවා නම් මේ highways කියන්නේ expressways highways නෙමෙයි අත්තර expressways. මෙහෙම lane එක තියෙනවා නම් මෙන්න මෙහෙම ඒවා ගහලා තියෙනවා highways මේ expressways වල. in other countries right this is fully filled with sand right if a braking issue comes especially for heavy vehicles right heavy vehicles වල ඔය vacuum brake නේ තියෙන්නේ ඒතර පොඩ්ඩක් case වැඩි දැන් මේ වගේ liquid brake නෙමෙයි මේ light vehicles වල තියෙන liquid brake oil එකෙන් තමයි ගිහිල්ලා brake pad එක මේ compress කරන්නේ right but in buses and other heavy vehicles there is a vacuum අර නැවතුවම කියලා යවන්නේ ඒක තමයි brake එකේ vacuum එක right vacuum leak එකක් ආපු ගමන් when there's a leak එක පොඩක් frequent brake is zero here when brakes are 0 මේගොල්ලන්ට මේකට දාගන්න පුළුවන්. දාලා they can safely stop the vehicle. ඒක තමයි ඒක ගහන්නේ. ඒක මේ වැත් හදනවා. මෙහෙ නෑ. හදුවොත් හොඳයි. මෙහෙ නෑ. right? ඉතින් අපේ මේ එහෙම බ්‍රේක් නැතුව ඔය කේස් උනේ මේ මම හිතන්නේ ඔය ඇල් එකත් එහෙම කේස් එකක් නේද අර මේ ළඟදී. මොකදනේ? අර මොකද බස් එකක් ගියේ මේ රාවණ ඇල්ලේ. දන්නවනේ මේ ජෙනරල් නොලෙජ්. ඒකට කියන්නේ බ්‍රේක් මොකක් හරි කේස් එකක් කියලා. අපේ එහෙම සේෆ්ටි එකට මොකුත් ඔප්ෂන් එකක් නැහැ. okay. C is correct. C is correct. B is wrong. B value ne. An object is rotating. An object in a rotating frame appeared to have no centripetal force as observed by an observer in the same rotating frame. In the same rotating frame ne. හරිනේ. මෙයාට centripetal force එක පේන්නේ නැහැ. In the same rotating frame. Right? An object in a rotating frame appeared to have no centripetal force as observed by an observer in same rotating frame. That is correct. Correct. B is correct. And C, both centripetal force and centrifugal force are required for the existence. I explained. Yes, it's a must, right? False second, only A is false. False only A is false. For 10D, answer 1. Only A is false. For 10D, answer 1. Right? Okay. Any questions from the questions we discussed up to here? All good? Online? Any questions? Quickly. Any questions from the questions we discussed up to this point? Quickly. Okay. Okay. Try next 5 questions. Only next 5. Right? So try next 5 questions. Next 5. What's the time? Exact time? 9:53. Okay, I'll give you 7 minutes. Next 5 minutes, 21 to 25. Right? 9:53 to 10. Okay, try this quickly. Next 5. Next 5. Find x5. Find x5 up to 25. So if there's any questions from the things we discussed today, you can ask before leaving the class. Right? If there's anything, ask before leaving the class. From Friday onwards, you have vacation, right? Full vacation. For 1 month. 1 month, you know? Okay, finished? Finished? Already? Still doing? Still doing? Okay, let's see. 21. Speed of the transverse wave of frequency 60 Hertz traveling along a straight string is 90 ms minus 1. The phase difference of two particles which are 75 centimeters apart will be. Right? So first thing, to get an idea about phase difference, we have to have an idea about wavelength. Right? We have to have an idea about wavelength of the wave. Right? So this is the wave. If this is the wave, now first I'm going to get an idea about the wavelength, lambda. Right? Apply V equals F lambda. V is 90, frequency is 60. Lambda, these two cancels. Lambda is 9 over 6. 9 over 6 means 3 over 2. Right? 1.5 meters. This is in meters. Huh? So let's convert this to centimeters. 150 centimeters, right? Which means lambda is 150 centimeters, right? Lambda is 150 centimeters. Then they asked about 75, which means up to here. 75 means where is lambda or 2, no? Right? Up to here. Okay, for a wave, this is how the phase angle changes starting from here, right? Very much similar to the sine and cos variations. 0, 90, 180, 720, 360, right? This is how it changes. 360 is also called 0 again because with respect to the circular motion, it is at the same point, right? When all 360 is rotated, right? Because any wave or any simple harmonic motion follows an associated circular motion, right? That's the thing. Make it I 0 කියලා කියනවා. Now about 75 now. 75 again half 5 180. For 25 it is 3. Half කියලා කියන්නේ 5. 5. නියම ගන්න පුළුවන්. Correct. What's the answer? Good. Next one. This is called 250 in physics, huh? Because in waves, in physics, no, in waves, because it is coming back to the same initial point with respect to the circle, right? 22. A person doing his morning exercises is shown in the figure. If he is at equilibrium by standing on his heel, the position of his center of gravity is most likely to be, okay, if he is standing still, where should it be? Now compare with the known scenario. Still standing still. Where is it? Hip and there is actually in this bisector line which goes through the hip. Hip එක ගත්තොත් ඒකෙත් center එකේ තමයි තියෙන්නේ. හරි hip එකේ center එකේ because we have a symmetricness, right? මෙතනින් symmetricness එකක් තියෙනවනේ. එතකොට මෙන්න මේ මැද තමයි තියෙන්නේ. Right? If we are standing still. Now he is bending towards this side, right? Heavier the mass towards the same side, the center of gravity displaces, right? The phenomenon, the behavior of the phenomenon, the behavior of center of gravity is always center of gravity displaces towards heavier side. Right? I think I explained this in one second. Right. Always center of gravity displaces towards heavier side. In one of the questions I explained. And about equilibriums. You know about stable equilibrium, neutral equilibrium, and unstable equilibrium in one of the questions. Then if he is in equilibrium, it says the person is at equilibrium. If there is at equilibrium, it should not be an unstable one, right? How it is becoming unstable? If center of gravity is, if center of gravity is outside the supporter, right? If center of gravity is here, if center of gravity is outside the supporter, it is unstable. If center of gravity is inside the supporter, that is stable. If center of gravity is at the end of the supporter, at the edge of the supporter, that is neutral, right? So therefore, at once we can remove C. C is outside the supporter. C එකට ආව කියන්නේ මෙයාට equilibrium ඉන්න බෑ. It falls. හරි කළා බලන්න. දැන් මෙහෙම කළා අර C කියන තැනකට ආවොත් you will fall down. Right? You will fall down. Right? අපිට මෙහෙම ඉන්න පුළුවන් until my center of gravity is coming to the edge of the supporter. Now the supporter is the foot. Right? මෙන්න මෙතනින් මේ foot එකේ line එකක් තියෙනවනේ. මෙතනින් පස්සේ ඉන්න බෑ. ඒක වැටෙනවා. ඒකනේ ඉතින් unstable equilibrium එක. එහෙම තමයි. Right? So C is wrong. So it should be a little bit ahead from the natural state. It is B, right? B. Hip එකේ තමයි කොහොමද තියෙන්නේ? හරි hip එකේ කොහෙද කියලා බලන්න තියෙන්නේ. It is at hip. So when we bend to these sides, it changes, right? The mass එක වැඩි කරොත් තමයි up and down වගේ යවන්න පුළුවන්. Say I'm trying to hold a heavier mass here. මේ මොකක් හරි heavier mass එකක් මෙතන තියා ගන්නවා. Then it goes up. Something like that. Right? So දැන් එහෙම මොකුත් නැහැ. That is B. 22. Answer 2. Anyone who has considered C as the answer? No. No. Online? Anyone who has considered C as the answer? C. C got to have the cow. There's one here. Others? No one? The problem with C is point C is unstable. It says there is an equilibrium, right? That is what it contradicts point C, right? Now, otherwise, if we are bending forward like this, displacement of center of gravity is forward, right? So, මෙතනින් ඉස්සරහට එන්න ඕනේ. But it cannot be outside the supporter surface, right? That's a logic. That's a logic. ඒ හින්දා C එක ගත්තා යා. ඒ හින්දා C එක ගන්න බෑ. දැන් C වෙන්න පුළුවන් මෙහෙම හිටියොත් මේ I'm not sure if the online students can see. No, you can't see. Now, if you have widen your legs and if you try to do this, එතකොට මගේ center of gravity වෙන්න මෙහෙට තියෙන්නේ දැන්. But still I can be stable because my supporter is now wider. That's the thing. මෙහෙම ඉන්නකොට මාව වැටෙන්නේ මේ knee එකනොත් එහාට මගේ මේ knee එක නෙමෙයි මෙන්න මේ foot එකනොත් එහාට center of gravity එක ගියොත්. Right? ඉතින් ඒක තමයි මේක more stable. Rather than this. Right? When we have spread our legs, it is more stable. Right? අර තමයි reason එක. Try later at home. Right? Try this. Keep your legs closer and try to do this. ආවනිකම් වැටෙනවා. ඊට පස්සේ leg මෙහෙම තියාගෙන බලන්න. ඊට වඩා ඔයාලට bend වෙන්න පුළුවන්. තවත් ඔයාලට gymnastic මොනවා හරි කරලා දැන් තව මේක උලන්න තව උලන්න. Right? කරලා නැත්නම් ඒක කරන්න යනවා. ඊට පස්සේ කකුල් කඩාගෙන අනිත් දවසේ class එකේ. Right? That's the thing. ඒක තමයි ඔගේ physics එක. That's why it's more stable. මොකද මම හිතත් මොකක් හරි කරාට ගැන කිව්ව නේද? කිව්වා. kinetic energy එක කිව්වනේ. ඉතින් කරාට වල මේ මෙහෙම position එකක් ඉන්නේ ඇයි? stable. මම නැත්තම් ඉතින් මෙහෙම විදිහට fight කරන් තිබ්බනේ. ගහපු ගා වැටෙනවා. ඉතින් එක පංච එකයි බිම. balance කරන්න බෑ center of gravity එක ගන්න ගම. right? ඒකයි ඔය ගොඩක් මේ fighting වල මෙහෙම position එකකට යන්නේ. මේට වඩා stable ගොඩක්. right? ඒක ඉතින් අනිත් movements උත් lazy. කියන්නේ kicks එහෙම lazy. plus there is more stable. නිකන් දැන් මෙහෙම ඉන්නකොට කෙනෙක් ආව push කරොත් වටන එකයි මෙහෙම ඉන්නකොට වටන්නයි දෙකක්. මෙහෙම ඉන්නකොට වටන්න අමාරුයි. Because my center of gravity is having a wider range when legs are spread. Right? හරි. That's the physics. ඒ ඔය හැම එකටම physics reason එකක් තියෙනවද? ඒක නිකන් කරාටේ වල මේ down යන්නේ නැහැ. ඒ කියන්නේ එහෙම down position එකක ඉන්නේ නැහැ. Stability. Right? ඔය දැකලා ඇති කරාටේ කරපුවා ඉන්නවද නැහැ? මොනවා හරි shows හරි බලලා තියෙනවා Olympics හරි මොනවා හරි games බලලා තියෙනවා නම් එහෙම දැකලා ඇති මේ සෑහෙන down ගිහිල්ලා position වෙලා ඉන්න fightersලා ඉන්නවා. Stability එකට තමයි. Advantages උත් තියෙනවා disadvantages උත් තියෙනවා. down යන්න මෙහෙට ගහන්න පුළුවන් chance එක වැඩි. ඒකට points වැඩි. Okay, 23. When 20 grams of water is at 100 degrees Celsius, it added to a certain amount of water at 30 degrees Celsius. The final temperature of the mixture is found to be 60. Right, listen. In thermal, when we deal with mixtures, right, this is called mixtures. In mixtures, always there is one substance which absorbs heat and there is one substance which liberates heat. Right? Once these two are coming to the equilibrium, it comes to the final temperature. Right? Because heat is also an energy. Heat is an energy. So above all, it should follow conservation of energy. Right? It cannot be destroyed. Therefore, it will be transferred. Liberated energy and released energy, liberated or released energy will be equal to the absorbed energy in the system. So as a whole, there is a constant energy. Got it? So therefore, we have to understand, we have to identify the heat absorbers and heat liberators. The easiest way to understand, identify an absorber is absorber increases temperature if heat absorbed. Right? It increases temperature. right? If heat liberates, it decreases temperature, right? Again, quickly බලන්න පුළුවන්. Temperature difference එකක් තියෙනවා. Temperature differences නැති cases තියෙනවා. ඒවට තව ක්‍රම තියෙනවා. Right now, for this question, since there is a temperature difference, from that you can look at, right? මේක තමයි argument එක. Total, see, total heat absorption equals total liberation, right? And Q can be written as ms theta. Q is ms theta. When 20 grams of water at 100 degrees Celsius, it is decreased to 60 now. Right now, final temperature is 60, which means both of the liquids are coming to 60 finally. Now, first liquid is coming down from 100 to 60, right? Temperature decrease, that is a liberation. That is liberation, right? May side liberation. 20 grams, no? 20, since it is grams, 10 to the power minus 3, right? What is it? Water. S is specific heat capacity. Specific heat capacity of S is not given, which means we can't use 4200 or something, right? So keep it as S, right? Theta, temperature difference, 100 minus 60. 100 minus 60. Theta is temperature difference, right? Absorption is by the other one. A certain amount of water, right? Let's say M, we don't know the amount of water, no? Same S, right? Theta, water at 30 and 30 comes to 60, no? The temperature difference is 60 minus 30, right? Always final minus initial, right? Or simply in heat questions, you don't have negatives, so therefore subtract the lesser value from the higher value, right? Okay, this is my equation 1. See, ms 30 equals, I'm not going to cancel anything, just keep it like this because we have to apply another equation. I'm going to keep this as 1, right? The next scenario, instead of 20, if 40 grams of water is added, final temperature of the mixture, right? Same thing, 40 grams will be added, but this is same, no? Then ms, final temperature is always, final temperature of a mixture is a value in between initial temperatures, huh? Now, if you are mixing, let's say, something at 10 degrees Celsius and 20 degrees Celsius, final temperature is some value in between 10 and 20, right? Therefore, now this is at 30 now. This is going to increase temperature. This should be theta minus 30. I'm going to consider final temperature as theta, right? Equals, this is 40 instead of 20, same as, and here 100 minus theta, because theta is something in between 30 and 100, right? Idea substitute. Okay, consider this as 2, and I'm going to divide these two, right? ms2, ms cancels, 10 to the power minus 3 to minus 3, s to s, that's all. Nothing cancel out. 20 times 2, right? Now this is 30 over theta minus 30 equals, here only 40 remains, over 2 times 100 minus theta, right? Simplify this. Now that's a simplification. First multiply and simplify. 0 to 0 cancels, that's all, right? 6, which means 600 here, 6 theta, 4 theta, 120, right? 720 equals 10 theta, right? Theta equals 72. 4. 4. These are the easiest types of questions we have in thermal, right? So just know. And about Q equals ms theta, you know this equation from O levels. MC theta, right? Now it's updated. Now we don't use C, we use S. S for specific heat capacity, C for heat capacity. It's updated. So in physics, don't use C, use S. Q equals ms theta. 24. the velocity time curve for a particle of mass m moving along a straight line is shown in the figure. Consider the following statements. Vd. Right. A. 24a. The particle does not return to its initial position and the end of the motion, at the end of the motion. How to check? Area, right? Area of Vd is displacement. Now, towards the positive side, it has moved from 0 to t0, right? And towards the negative side, negative means coming back, returning. Return motion is also the same distance, because these areas of two triangles are equal, which means it comes back to the initial position. The particle does not return, wrong. It does return. It does return to the initial point. It does return to the initial point because areas are equal. The logic is areas are equal in positive and negative sides. Areas are equal. B. Acceleration of particle does not change during the motion. Correct. No. What is it? Correct. Wrong. How to check acceleration of a Vd? Huh? How to check acceleration of a Vd? Gradient, right? If gradient remains constant, acceleration is constant. Gradient is tan theta, right? Acceleration is gradient. Gradient is tan theta, right? Simply, this is slope. That is the exact same slope from 0 to t0 10, t0 to 2t0. Exact same slope, same slope, same slope, same angle, same slope. This is actually a positive constant gradient. So that is a constant acceleration. Acceleration is same throughout. It is correct. It is correct. B is correct. B is correct. Acceleration is same throughout. Correct. C. At t equals t0, the impulse acting on the particle is 0. Impulse. What is impulse? What is impulse? Impulse. Change of momentum. Ft. Impulse is Ft. As an equation, impulse is I is Ft. It's also can be written as delta mv. This is called impulse. Right? This is called impulse. F is when there is an acceleration. No? If there is an impulse, right? Let's go this way. If there is an impulse, which means F should be non-zero, isn't it? If F is non-zero, acceleration should be non-zero because F equals ma. No? Now it says at t equals t0, impulse is 0. If in order to impulse be 0, acceleration of the particle should be 0, right? What is acceleration of the particle at t0? Is it 0? No, it is not 0, right? Slopes directly. If acceleration 0, gradient should be 0. So that is non-zero. Therefore, impulse is 0, that is wrong. Impulse is non-zero because acceleration is non-zero. Right? Only B is correct. Only B, 2. Only B is correct. Only B is correct. 25. 25. Two wires of same length are under the same tension. Two wires of same length are under the same tension. The fundamental resonance frequency of one wire is 4 times of that of the other wire. Two wires of same length are under same tension. See, waves. Two wires of same length under same tension, same T, right? Same length, let's say L each, same tension, right? The fundamental resonance frequency of one wire is 4 times that of the other. Okay. So this is a fundamental wave pattern we have on wires. This is a fundamental wave pattern we have on wires. Right. So about frequency is given. right? So we know this is one loop means lambda over 2. Lambda over 2 equals L now, which means lambda equals 2L. Now, even if you can't remember the proved equations, still you can do the question like this, right? So that's why I'm explaining this. Lambda equals 2L, right? Then apply V equals F lambda. Apply V equals F lambda. When I get lambda, can you see that lambda is same, right? For this one also, you will get the same. Lambda equals 2L for both, right? Then apply V equals F lambda for them one by one. And the question is about areas, right? Diameters. Diameter is with the area, right? We know V of a solid medium, velocity of a wave in a solid medium can be written as, there are two equations. V in a solid medium can be written as either root T over M or root T over rho A. Since we need diameter, I'm going to go with this equation, right? We'll be using this. Now apply V equals F lambda for this. V equals F lambda. See, V can be expanded as T over rho A. If diameter is, let's say, for this first one, diameter is D1. For this one, diameter is D2. Right? Diameter ratio. And just know that always ratios between diameters and radii are equal or different? Equal. Ratio between diameters and radii are equal. Because 2 times radius is diameter. For the other one also, there is 2 times. Ratio remains same. Right? So therefore, without writing that unknown that 2, because if I'm using diameter, I have to write d over 2. No? I'm going to get the ratio of radius at once, because it will be same as the diameter. Right? Area is phi r squared. Then this is phi r1 squared equals f. About f, there is given something. The fundamental frequency, resonance frequency of one wire is 4 times that of the other. We make a f, make a 4f kilogram. Right? Then f lambda is same anyway, 2L. Do the same for the next one. Right? Root T over rho A is phi r2 squared equals 4f 2L. Divide these two equations. See? Now, if I divide these two, root T to root T cancels, right? Rho to rho, phi to phi cancels. From here, root 1 over r squared, r1 squared remains, no? Its root is 1 over r1, right? Kilimma make 1 over r1. And this is the reciprocal value. Reciprocal value of this is r2, right? Equals 2L to 2L also cancels. F to F also cancels. Then 1 over 4. 1 over 4, right? Hurry, it's an answer 1 to 4. 4 to 1 kilogram bila nahi nahi naman kelim mein tinggal 1 to 4. 1 to 4. That's it. 1 to 4. 1 for 25. Answer 1. Right. Listen. Okay. 25 questions are discussed, are written and discussed, and another 25 questions remaining. Right. Complete all 25 at home, and about the answers also, I'll be doing the same. I'll be uploading the answers for the MCQs, remaining MCQs, to the website by next Sunday. Right? By next Sunday, you can use this time to do remaining 25 questions and check answers, and I'll be taking the special questions from remaining questions, not the same types we have discussed before. If there are new types, I'll be taking those special questions to the discussion on next day, right? And the next paper is going to be a part 2 essay, right? Okay. Any questions? And the physical students, when you enroll to the website, upload the invoice given by them, given by the institute there, and get the approval, right? Create because next month onwards we'll be planning to update marks on the website as well, right? Next month onwards, so better keep it created. Online ones, you have it anyway, no? Okay. Any other questions? Anything to clarify from the discussion? Any other questions or anything to clarify from the discussion? There's no point of touching and go. I mean, touching and go in these questions. So that's why I'm explaining all the background theory when explaining a question, right? Because if you learn one question in the right manner today, you won't do a mistake again for the same type. That's the thing, right? Otherwise, now I can discuss this much faster without recalling about the background theories much. Without recalling about the background theories much. But since you are still just started to write papers, right? One of the main purposes actually of writing papers is not just the mark, but broadening your knowledge, increasing your knowledge, right? So that's why I'm explaining all the background in a question, right? So take that advantage. So which means when we are moving towards the other discussions coming up, right? Sometimes I'll be quickly moving because I have discussed them already here. I have explained the background theory already here. Now let's say another question came on another day from reference frames in circular motion. I'm not going to explain this way, right? Since I have explained already, we'll be doing much faster, right? So that's why it takes much time for these initial discussions until your knowledge is taken to a kind of a satisfactory level, right? That's why, because always the main purpose of writing papers here is not the marks yet, right? I didn't focus on any marks yet, right? Main focus is the knowledge, but yet we will be starting to mark papers next month onwards, most probably, right? Because for paper marking, I'm planning to get 2 or 3 students from this batch, 25 batch. So once their A levels are over, right? Let's see, right? That's a plan we have. Then we'll mark the papers and you will get the mark, right? But still, my main focus is broadening your knowledge on these areas. If the knowledge is there, increasing marks is not that difficult, right? The basics, foundation, and the knowledge is the key here. Knowledge when you are tackling a question, that is like a kind of a hassle-free or much easier thing if you have the solid knowledge. Knowledge that's the thing. Okay then. No questions? Right. Okay, so if there's no questions, we'll wind up. So get ready for an essay paper next day, right? Part 2 with the structured essays and essays. And I'll be including questions up to optics, right? And I'm not planning to include any essay questions from thermal yet, right? Because we haven't covered thermal, right? I just included few MCQs here just to give an idea, right? So you will get questions up to optics, right? Okay then we'll wind up. All right, go safe and stay safe, study hard. See you all on the next class. Goodbye and good night.